Good morning and welcome to today's webinar, the second session of a two-day seminar. My name is Emily Kobier-Schell and I am a member of the Build Up editorial board. Build Up is Europe's largest international portal for energy efficiency in buildings. It is a unique community that provides the opportunity to discuss, contribute, and collaborate with other experts in this field. Build Up aims to bring together stakeholders working in the building and construction sector to reach the collective intelligence about energy reduction in buildings by encouraging knowledge exchange. Our editorial work is organized around the topic of the month, which allows us to dig deeper into specific themes. Each month, several items are produced by Build Up, such as overview and technical articles and written interviews, but that's not all. Build Up also offers the opportunity to host webinars on topics related to energy efficiency in buildings. More recently, Build Up has opened its doors to distinguished experts in the field to share their knowledge in front of our cameras in our Build Up expert talks. The Build Up portal shares daily the most relevant events in the field of energy efficiency, but we also participate actively in many European events around the year, such as the PP Center and REBA conferences, H2020, Interreg and Cost Action events, Covenant of Mayors, and more, always with the aim of further disseminating their results and helping to create high-quality media content. The Build Up portal is updated daily, reaching around 120 new items each month, including news, events, publications, articles, and video content. But Build Up is not only us. Build Up is a community, and we invite you to be a part of it. By becoming a member, you can contribute by uploading your own content and promoting your project news, events, case studies, reports, and more. By contributing content, Build Up will help you to reach a broader audience through our online portal, our social media channels, and our monthly newsletter. Visit us at www.buildup.eu to find out more. It is a pleasure for Build Up to host this two-day seminar entitled Microclimate, Change and Envelopes, Understanding, Modeling, and Design in Light of a Changing Climate, brought to you by the Urban therCOM project and curated by senior researcher Emanuele Giancola and Professor Emanuele Naboni. The seminar is focused on the relationship between the local microclimatic changes and the design envelopes and will take place over 2 days. In yesterday's agenda, keynote speakers introduced their work and upcoming challenges related to climate change modeling, coupling of microclimate and building forms, envelopes via computational advanced workflows. And the agenda for today will center around matters of decarbonization and energy, health and comfort, ecology, and nature-based solutions. So in today's agenda, we'll start with this quick intro, and then we'll pick up where we left off yesterday and start with the fourth session, which will cover energy and climate change. We'll hear first from Andras Reit from ABUD, then Umberto Berardi, Toronto Metropolitan University, Polytechnic University of Bari, Gabriele Lobacaro and Mattia Mani, Norwegian University of Science and Technology, and Giovanni Betti from HENN. This will be followed by session 5, which will focus on envelopes in light of climate change, where we'll hear from Jesus Lizana, University of Oxford, Miriam Juaristi, from URAC, Yanis Kousis, University of Perugia, Alessandro Canevale, Polytechnic University of Bari, and Fabio Favino, Valentina Serra, and Stefano Fantucci, Polytechnic University of Torino. In our second to last session, session 6, we'll cover nature-based envelopes for climate change. We'll hear from Roberta Cocci-Grifoni, University of Camerino, Katia Perini, University of Genoa, and Maria Beatrice Andrucci, University La Sapienza, Rome. And each session will, of course, be followed by a brief discussion. Then in our final session of the event, called Linking Scale, Tool, and Design, we will hear from Emanuele Naboni of UniPR, Royal Danish Academy, UNSW, UC Berkeley, SOS Mario Cucinelli. Then before rounding off the event, there'll be a conclusion and discussion session moderated by our moderators today, Emanuele Naboni and Emanuele Giancola. We invite the audience to send us questions through the GoToWebinar platform that may be answered during the discussion sessions. Please specify who your question is for. You'll be able to find the recording on the Build Up portal together with the presentation slides and also on our YouTube channel from Wednesday next week, which is also when we will be launching the brand new Build Up portal. So keep an eye out to check it out. Now I will hand directly over to our moderators, Emanuele Giancola and Emanuele Naboni. The floor is yours.
Hi.
Yes.
Good morning. Sorry, Emanuele again. Good morning. Good morning, everyone. We start this webinar that's called Organizing the Framework of the Thermal Urban Project here in CIEMAT in Madrid. And we start with session number 4 related with energy and climate change, and give the floor to Andras Reit.
Yes. Can you hear me?
Yeah.
Yeah. Thank you. Hi, everyone. My name is Andras Reit. I'm an architect from Hungary, specialized in sustainable design. And yeah, please, can we start with my presentation? Yeah, thanks so much. So, and next slide, please. I would like to talk about, yeah, unfortunately not about mountaineering. However, I think is very important to focus on the issue of climate change, and I like it very much to personalize some issues like this. So I like very much mountaineering. I go often into the mountains and nature. And next slide, please. So you can see in those pictures, and just to be aware of the magnitude of the problem that we are facing, because normally if we are tackling, you know, the problem climate change, we are talking about 30, 50 or 100 years. And I just would like to share two photos of two of my expeditions to the same spot on the Earth. And you can see that within 16 years, how unbelievable change happened in the nature. So next slide, please. So to talk about these problems a bit more, and you are very much aware of those numbers, what the buildings are responsible for. Of course, and the next slide, please. Of course, it's very important to talk about sustainability. However, to be honest, how many of you read the Brundtland report in details and understood it? I think those things like, in general, sustainability sometimes is a bit too complex. So we try to understand it and translate it for us as architects. And the next slide, please. What does it mean for us to work in this environment? And I think it's very much or very important to focus at least on 3 different areas where we are working as architects, which means we are working a lot with humans, of course, the built environment and the nature as well. With all of these are in the so-called interactions, which means this is not a one directional action, but we will receive something contra what we are doing. So, and this is a very important issue to understand, that all of our acts are actually interactions with our surroundings. However, it's very important that in the last couple of decades, we have platforms or tools to evaluate and quantify those actions very well. Next slide, please. And as architects, it's very important to understand that our actions, what we are doing, is actually influencing all scales on the Earth, which means if we are working with buildings, of course, that will interact with the cities, but the smaller ones, the components like buildings or even the building components, is an important scale for us as architects. And today, next slide, please, we will much more focusing on a very special and many times for many architects, the most important issue, how our buildings look like. And so talking about the whole envelope, I would like to concentrate mostly on one special issue, and those are the thermal insulation and thermal transmittance of a specific facade. And I would like to address one very important issue. And next slide, please, which is mostly about the problematic of overheating of our buildings. And you know very well that in Europe we have a kind of regulations. We call it EPBD, which is related to the thermal performance of buildings. And of course, we have different regulations, specialized regulations regarding the building envelope. Next slide, please. And in general, actually, we address this issue since many decades, and we think that if we insulate our buildings more, then actually the outcomes, the result is an increasing energy efficiency. However, I would like to share one case study with you where we studied how to optimize the building envelope. The next slide, please. And this is an office building, so it's very important that I am talking about a special function, which is office, and I will explain it later why is it so important. So it's a quite huge building, so around 130,000 square meter, located in Budapest, so in a continental climate. Next slide. So of course we did a lot of simulations and modeling work to optimize the whole building envelope and the shape and everything around the building. Even we did several CFD simulations to study the microclimate around the building. In the next slide. And because of those complex simulation works, next slide please. Because of those complex simulation and optimization work, we could achieve that we could decrease the primary energy demand of the buildings. However, if we are looking into more detailed into this building, next slide please, we will see that the primary energy distribution in the whole is a very much cooling related. So it's in office buildings, like in climates like in Budapest, actually your office building is a cooling related issue. And you can see that the heating is more or less not so really important. And if we are looking into the next slide, then you will see that we did several optimization processes. So we looked into the climate change scenarios, but also in a process how the EPBD is going to be more stronger and stronger, which means that you will insulate more and more regarding those regulations you're building. Next slide, please. And you see that actually it is contra-affecting the energy efficiency, because if you are comparing the results which relates to a less insulated building, comparing with a much more insulated building, and also looking into the climate change scenario where the boundary conditions will change and the climate and the microclimate will be very simple way hotter, then you will have a much higher energy demand in the building. And just to explain this, next slide please. Think about that if we have let's say a normal conventional building envelope and we put more insulation on the building, and the next slide please, and we put of course internal gains into the building, next slide please, it will be much complex way to let the heat going out through the building envelope. And what will you need in this case? Next slide, please. Of course, a kind of artificial system to cool down your building, which will affect at the end that you will have a much higher energy demand in the building. So next slide, please. So I have to say that in many cases, especially in the southern countries or in climates like Hungary, so continental climate, is not only the U value what counts. So I think, and the next slide, so we have to rethink very much, for example, the EPBD regulation. Next slide, please. So it's not really the recast what we are aiming for, it's much more rethink. And the next slide, what you can do, of course, studying several aspects regarding your building design. For example, window to wall ratio. This is an example again in Hungary. So if you don't build a fully glazed building, but you just have more or less 30% window to wall ratio, then you can achieve those numbers. So you can decrease the cooling energy demand or even the heating energy demand in specific buildings, or even, and this is what I would prefer actually in the future very much. Next slide, please. Using other possibilities like nature-based solutions around or in buildings. And we did a huge meta-analysis where we studied scientific publications about case studies globally, and we specified those effects, what we could have from plants or nature-based solutions around the buildings and in the buildings. And you can see actually how could this affect or building energy demand in the future. So this is shortly what I wanted to address in this short presentation. So thank you very much. Next slide. So if you have any questions, we can discuss it further in our Q&A session. So thanks so much.
Thank you so much, Andras, for staying in time. And very interesting presentation. We probably will have some questions and later, and we leave the word to Mattia.
Umberto Berardi sent the presentation, so I don't know if we can have his presentation.
Is Umberto Berardi connected?
I didn't see it, but he just write me an email, send me the
Okay, let's go with Mattia and then we see it. Please, Mattia, go on.
Okay, yeah. Yeah, can I have the control of the slides, please? Okay, yeah. Okay, so yeah, good morning, everyone. I'm Mattia Magni, and I'm going to present in brief my research about solar energy at high latitudes. So let's begin with some information from the latest report from IPCC. And as most of you are aware, I mean, every of you is aware of, by 2050, we are expected to reduce carbon emission from the building sector by 66%. What not everyone is aware of is about the potential, I mean, to which extent solar energy can contribute to achieve this target, both in terms of renewable energy supply and in terms of increased energy efficiency of buildings, so passive solar gains. However, the uncontrolled and unplanned exploitation of solar energy can result in land use and habitat loss. And this risk is quite real due to the fact that unit cost of solar technology has fallen consistently, and these technologies have been widely adopted in the market. We experienced this trend in Norway as well, where the solar powered capacity that is installed in the grid, in the national grid, has increased tenfold during the last 5 years, and this trend is expected to be confirmed in the future. This is because, of course, of new opportunities that just pop up in the market. I mean, IPVs, but those are not so new, but also agrivoltaic system or floating PV system. Therefore, there is a need for tools and platforms that can provide support to designer and urban planner. And here comes the sun of Helios in this case. Helios is the project I'm working on. It's a project that aims at developing a solar cadastre for citizen, for the community. So a solar cadastre is a 3D solar map that can be accessed by the citizen to optimally exploit the solar energy potential of their buildings. And this project is built on 4 pillars. Pillar 1 and Pillar 2 concern the input parameter of the solar cadastre, which are the solar data sources and the geometry volume. So pillar activities within pillar 1 are focusing on the investigation of solar data sources, both numerical analysis and satellite observation, but also ground measurements. So we established a ground monitoring network at the university campus, which is equipped with several pyranometers installed with different orientation and tilt angle. And there is also a sun tracker that can provide measured quantities of direct and diffuse irradiance, which is not so common everywhere. And then there are several PV system and PV and solar models installed around the campus that are continuously monitored to provide an overview of their performance degradation. Regarding pillar 2, the objective of pillar 2 is to develop a protocol and a methodology to reconstruct semi-automatically the building volumes with a high level of detail, which is the level of detail 3, which is usually the mostly used in the energy simulation. We want to recreate the building volume from drone flights or from LiDAR scanning campaign. So we are focusing more on semantic reconstruction of the facade element and reconstruction of the building volume. So in this pillar. Pillar 3 is the one I'm more working on together beside pillar 1. So it's solar irradiance model chain. So the simulation engine of the solar cadastre. The model chain is composed of a decomposition and a transposition model. The first model usually decompose global horizontal irradiation into direct and diffuse fractions, and then we have the transposition model that transposes these two quantities into a global tilted irradiation of any surface. So is the core of the 3D solar map. Pillar 4 is not what I'm really working on, but we have part of our research group that focus on citizen engagement. We want people to use the solar cadastre, so we try to involve them in the development and in the design of the cadastre properties. And in this slide, the main activities and application of the solar cadastre and the simulation engine of the solar cadastre itself I'll summarize. So you can see application 1, results can be applied to advanced photovoltaic simulation. We can use the simulation engine to investigate the energy production of bifacial PVs, which are increasingly important here at high latitudes, but also color photovoltaic cells and photovoltaic plants that are partially covered by snow. This is a case that happens quite often here, and of course we got some loss in the energy production because of the snow accumulating on top of PVs. And application 2 is actually wrong. The images are the one on application 4 and vice versa. So solar neighborhood planning is, solar neighborhoods are just neighborhoods that can exploit solar energy in an optimal way without any specific target, like related to zero emission or positive energy. And that's what the solar cadastre can be used for. Application 3 is about KPIs. So we are focusing on reviewing KPIs regarding solar energy and solar energy performance of building, and selecting the one that can be more significant for citizen or for the user of the solar cadastre to be used in the online version. You can see in this slide a screenshot of the interface of the solar cadastre of Geneva, which is already online and used by the population. Then application 4 is about Arctic decomposition models. Decomposition models are most of the time developed and validated with data from a specific location. We would like to, the goal in this case is to develop and validate a model for high latitude location, which present characteristic in terms of atmospheric condition different from the one of the tropical area that are the one. I mean, the tropical area is the mostly used when it comes to the composition model development and validation. So we would like to have an Arctic decomposition model that can be developed specifically for us, I mean, for these locations. Yeah, so just 3 take-home messages from this brief presentation. That solar energy potential can contribute to reach the reduction in terms of emission that we want to achieve by 2050. That there are many opportunities for solar energy at high latitudes also. It's not always dark. You can see how bright it is today from the camera. And yeah, that there will be a tool to support you in designing solar strategies, even if you're not living in Trondheim. I mean, Trondheim is just the first step. Then we will build up more solar clusters. So, and some others already exist. So, I mean, it's a matter of finding them and using. Okay, so yeah, within 10 minutes. And thanks for your attention. And yeah, we can discuss about our activities.
Yeah, thank you, Mattia. You are really bad in time, and your research is really interesting. So we think we can go now with Giovanni Betti, because we are still miss Umberto Berardi, but apparently he joined us. So Giovanni, yeah.
Yeah.
Because we need to share your screen, okay?
Yes, please make me the presenter, so hopefully a new button will appear and I'm able to do that. Yes, wonderful. Show your screen. Okay, can you see my screen?
Yes.
So
yes,
yeah,
perfect.
So hi everybody. My name is Giovanni Betti. I'm going to be talking quickly about a project that I've been working on for the past couple of years and still under development, called CBE Clima. Just before that, a couple of words about me. I'm an architect. I am currently head of sustainability at Hen Architects in Berlin, and I'm also a guest professor for digital and experimental design at the University of the Arts here in Berlin. And a bit more about me. I started my career as Foster Partners, where I was in a team called Specialist Modern Group for about 8 years, where I was associate partner. Then I'm in practice. Then again in practice here at Hen for about 5 years, leading a team called Performance-Based Design. Then a short 2 years in academia at UC Berkeley as assistant professor for architectural design for building performance. And now I'm splitting my time between practice at Hen, trying to set up and lead a sustainability department, pushing our building to be carbon neutral, and also at the University of the Arts here in Berlin. The work that I'm presenting here is a work that I started at Berkeley and continues, and it's CBE Clima, an online open source climate analysis for the AEC industry, for the architecture, engineering and construction industry, but also for the education in these fields. And this starts from a basic consideration. Climate responsive architecture is nothing new. We have a lot of very beautiful vernacular historic example from the wind tower of Yazd to the village, very well adapted to the wet and humid condition in Indonesia, to beautiful city planning example in North Africa. And climate responsive architecture in the face of the climate crisis is allegedly always more important. And this is something that, while climate responsive architecture is nothing new, climate analysis is actually a modern intervention, probably modern with the capital M, in the sense that it relates really to the modern movement and to this sort of breaking point with tradition that came with industrialization and with the modern movement. So at the turn of the 20th century and after the war, there's really been a shift in how architects would deal with climate, treating it really as a specialist subject. And this has also led to a series of developments in creating the science of microclimatology, how the topography affects microclimate. There are a lot of beautiful, fascinating graphics that has been done, how to describe this actually quite intangible aspects and how they interact with the built environment. I always find fascinating these workmanship test huts by Frederick Bugge in Norway, trying to understand how different construction respond to climate. And this is probably the first time that modern climate analysis appears in this American Institute of Architects regional bulletin in the 1950s, where they start publishing statistics of climate and how these could impact the architectural design. And this brings us to our current situation, where unfortunately it's an activity that is so fundamental, I think, to the design has become somehow a niche and time-consuming task. There are specialized programs that needs to be downloaded. Of course, here Climate Consultant, which also is a program with a long history, let's say, or the state of the art is also like this kind of chain of tools. So with Grasshopper, Ladybug, or Climate Studio, or whatever, but it's essentially a software within a software. So it gets quite specialized and technical and requires quite a lot of knowledge. And that was, for instance, also kind of the way I was doing this professionally in my work, building time over time this monster definition, adding graphs and adding specs, and this was actually working relatively nice. It would, that monster definition that you saw there would then spit out a 40+ pages climate report with all the graphics. But again, the problem is specialization, and for something that should be such a basic activity. So that's where Klimatool comes into place, and the goal in creating Klimatool was to create a tool that was easy to access, easy to use, easy to understand, and flexible. For those of you that are interested, it's mostly in Python, and we use PyThermal Comfort as one of the main libraries for specific to the psychrometrics and PVlib, and we use Plotly for creating all the graphs. And this, again, easy to use, easy to access. It's all, the code is under MIT license, which means you can take it and remix it and reuse it and do whatever you want with it. And all the graphics are under Creative Commons. Use them for any purpose, educational, research, and or professional. Klima works like this, and maybe I'll switch. Let's see if I can switch to a live demo. Maybe somebody can make some noise that you see now a web browser. But essentially works quite simply as a series of tabs that you move from left to right. You start with a word map where you can zoom in and select the weather file you want. So now I'm in Berlin, so I'm gonna pick one in Berlin. And yeah, and then essentially you move through the tabs. left to right, but you can also jump in between. So we start with a climate summary where we give you back a map, so you sure you pick the right place, some basic statistics. You can download the EPW and you can download the climate data frame. We calculate a lot of other values on top of the EPW. And then you have basic stats like cooling, heating and cooling degree days as a basic starting point for the climate. And one thing that we wanted to do is that all of those graphs are highly interactive. So when you have nice mouse over events, you can select, you can see only certain aspects of it, only the heating degree days or only the cooling degree days. You can say, well, actually, I'm interested in 15 degrees as a base, not 10 and 18. And the graphs interact. Again, and then going in further levels of detail, temperature and humidity as the main variable, yearly chart showing minimum and maximum overlaid with the adaptive comfort, monthly averages, and heat map charts. And again, everything is extremely interactive. So if you are interested only in certain months, you can zoom in there, and everything is downloadable as a vector graphic. So you just click on this and you have it immediately as SVG, so which means that you can put it in Illustrator if you want to process it, or just in your PowerPoint presentation, can be printed at any resolution, can be edited, can be changed. And then again, increasing level of complexity, sun path. So we create the sun path. That's not in the EPW, but we have the informations. You can overlay all the other that you have available, so dry bulb temperature, or if you want to know what is the radiation in relation to the sun path, or if you prefer a Cartesian to a spherical plot, you can do that as well. You can have a diffuse and global horizontal solar radiation throughout the month as the plot throughout the day. A breakdown of how often it is cloudy, intermediate, or sunny sky in Berlin. So with all this and emphasis on climate, I clearly chose the wrong place where to live, but that's another conversation. And again, being able to drill down and moving forward, we can go look at, for instance, wind, where we provide you with wind roses. Again, here, for instance, if you're interested only in seeing the strongest winds, you can select only those and see what is the wind rose there. So this kind of idea of interactivity and so on. And it keeps on going. It gets progressively more technical. If you wish, so psychrometric chart where I can look at the frequency or I can plot data on top of that. We also trying to get closer to design. Am I running over time?
Yeah.
Okay.
That's it.
So I'll let you
Sorry.
into it. No, it's fine. And I will just say, so we do also a number of things. So if I have the only thing that I can say, we also offer here at the bottom of the page, you have a very rich documentation that explains everything that happens in the website in rich detail. So I will leave it to that, and we can talk more in the Q&A.
Discussion session. Okay. Thank you. Thank you very much, Giovanni. So we now leave the floor to Umberto Berardi, that is now with us. Hi, Umberto.
Okay.
Can you hear me?
Good morning, Umberto. You have 8 minutes. The floor is yours.
Yeah, I will be super fast. Don't worry. So I don't know. I was actually connected, but I was on a wrong link, whatever. Should I share my screen or do you share my screen?
No, I'll share it for you. I'm going to give you the controls. One moment.
That's okay. It's okay. It's okay. So, you know, I selected the kind of a topic that it's a bit bigger than the envelope, because what I want to describe with you is what we've been doing over the last few years in Toronto, North America, Canada, where we've been creating an urban building energy model that really helped us to challenge the multiple, changes that this city is experiencing. So next slide. because now unfortunately you're sharing a PDF, but I'm more than happy to share the PowerPoint later on. In brief, what is happening in the city of Toronto is that what you see used to be a very low-rise construction. You see a very low-rise buildings typology typically, but what has been happening is that on the river there are now basically 100 buildings with a height above 100 meters. So basically all these area that is in green has been actually subject over the last 15 years to a significant development with a lot of new kind of challenges. So next slide, what I've been doing is trying to work with the city of Toronto to make sure that we can guarantee to this core lakefront part of the city a more sustainable trajectory. And I'm more than happy actually if you could later on get to this link to get a sense of this urban building energy map that we've been creating with the support of the city of Toronto. So next slide, just to give you a snapshot of what the map looks like. We've been working on creating, thanks to the availability of a lot of data, and I know in North America data are more easily accessible that you typically have in Europe, but we've been creating an energy map of the city of Toronto with a very good granularity, with a very great actually capability to go into the details. If we go to the next slide, the map is a 3D map. With this 3D map, we are able to kind of check for single blocks the energy demand dynamically with a resolution weekly by weekly. So we are working now to kind of increase the timing resolution, but what we have been already achieving is a good possibility to get actually a planning of the energy demand that is good enough. And we've been doing now, more deeply investigation with some neighbors that are facing a significant development. Next slide. What we've been doing with this kind of maps? Well, mainly trying to direct the planning of the city, trying to make sure that we know what is the energy infrastructure needs to be put in place, and trying to promote a deeper penetration of renewable energy technology opportunities within the city. There are still some concerns with privacy. There are still some concerns with the amount of data we are dealing with. The data clearly is a big part, but also the visualization and the capability to take actually advantage of the availability of data. But more recently, we've been taking this map to try to look at resiliencies and climate change impacts on the city. If you go to the next slide, please. What you're going to see is basically a snapshot of a very powerful tool that Canada has made available for all researchers. That is called a Climate Data for Resilient Canada. This is a web page of the Ministry of Environment of Canada. So this is basically an high resolution, detailed IPCC for Canada. Let's put it this way, with all the scenarios, with all the kind of impacts that different measures are going to have on climate data, in 10, 20, 30, 50 years from now. So if you go to the next slide, you can get a sense of what I'm meaning. Basically, you can zoom in, get, monthly by monthly the energy demand. And if you start, zooming it, you have a resolution of 50 kilometers by 50 kilometers. So it's quite a good granularity that Canada is made available for us. So next slide, with this data, we've been trying to couple this, metadata with a bit of micro scale data to try to kind of use a WRF to try to get from this national wide data to something that is more granular for the different neighbors of Toronto. If we go to the next slide, the idea is been actually typically to look at the impact once we go to Toronto. And the impact is quite dramatic. If you use the ASHRAE characterization, Toronto used to be in zone 6. These days it's in zone 5, but it's already more or less moving towards zone 4. So what is happening is that this continental climate is experiencing a significant challenging over summer waves and summer heat demands. Just to give you the sense, last year Toronto had a heating degree days that was only the double of the cooling degree days of the city of Toronto, which is actually astonishing if you think about that. So if you get to the next slide, I don't have time to go into details, but basically the idea is that we have been taking the typical national-wide weather file, coupling with future weather files, creating these models applicable to smaller scales, to the neighbor city scale. And with that, we've been trying to do a bit of forecasting analysis of the weather in at the urban scale. The good value is that we take the advantage of the larger picture of the planet trend, but then we downscale, quite significantly to get the available information useful for our modeling. So if you go to the next slide, clearly, if you go to our webpage, there is a significant number of studies that we've been doing with this kind of data. The idea has been often, try to compare different scenarios, try to compare different options. Option in terms of intervention, option in terms of penetration of renewable, option in terms of decarbonization targets. So with the availability of all these data, and more importantly, with the availability of these data applicable at the urban or at the microclimate scale, if you can get to the next slide, what we've been doing is in a number of studies on the energy impacts of different things. So clearly, the availability of data creates the opportunity for doing a bit of planning. The opportunity for a bit of planning needs to be automated with modeling that has to include, a bit more power, in calculation, but that's, these days available in most of the research center. And with that, we can do, different optimization targets. So we go to the next slide, or even 2 slides from now, because basically I'm now just showing you a bit of picture. So we've been doing, so this is how the Toronto weather file will change. You can see the drop in the heating degree days from, being about 5,000, already in the range of 4,000, significantly, expected to drop below 3,000. Next slide. So what we do is energy planning at the city scale. So here is basically for all the archetypes in the city, you see the energy demand change, shifting with different, models to forecast the future weather. So with that, I conclude. There are another couple of slides that are simply looking at, an iteration of this approach, but I think actually the big picture is, cooling loads clearly are supposedly to increase, even in North America, heating degrees significantly dropping, and being able to anticipate this trend once we do a bit of, energy planning is really our key and hopefully, valuable contribution to the community.
Fantastic, Umberto. Thank you so much for your contribution. And we ask all the members of this panel to please switch on their camera, and we have a small debate. We are collecting a question from the audience too. I think this was an impressive session. We have had different projects, this ranging from, let's say, regional models up to a charting of climate, and then going into the details of how solar collection can be amplified within the Northern Air context. And finally, we had a very interesting project related to a specific case of facade application. So we collected some questions. The first is actually for Andras. So the question is, you are also doing an intensive activity as a researcher. How has been important, this is a more of a generic question, keep that side of research as an influence in your design, and how is this impacting the design? Yeah, that's the question.
Yeah, that's a very, very good question, but I think this problem is not only addressed to persons who are doing, let's say, research and design together, but in all of our designs, and the colleagues from Hen Architects could, I'm sure, assure us as well that in the early stage you have to make a lot of decisions which will influence completely the whole design and the whole performance of the building. Of course, not only from the environmental but also economical point of view. So you really use tools from the early stage, and you should have a kind of scientific approach from the beginning in such design, what you are doing, if you wish that your design at the end performs on a very high level. So it's, but personally very well, you are working as a consultant as well in the field of architecture. So, but we do a design regarding our results from research and scientific results.
Sure, that's a super interesting loop, being practitioner and researcher at the same time is something that we can see enriches the projects. Second question for Mattia. That's an interesting question, a little bit challenging, I must say. The question is related to if you have done any studies about the thermal impact of having photovoltaic panels into a city and the relation to urbanite island. I have to make some premises that you're clearly operating in a northern climate, but you're also part of European projects. So perhaps Mattia, if you have any insight about the balance between photovoltaic and their contribution or not to urbanite island.
Well, we are still not at that point in the project. Now we are just mostly focusing on the optical part. We haven't investigated yet the thermal domain, to be honest. But we have many, I mean, you have seen them actually, some facilities, like we have a huge office building, a 4-story office building that is actually a pilot and is controlled with sensor, also thermal sensor that are installed on the BIPV facade. So it's part of the project, not yet started, let's say. I mean, we are just at the monitoring stage. We are collecting data, but yeah, with the next step. For the time being, we are just focusing on the optical domain. So yes, maybe next year I will reply to your question.
The fact that you put the thermal sensor is very interesting. It will not only be related to the thermal performances of the system, but also to the effect on the microclimate. So that's a very relevant question. Giovanni, so there is a comment. Thanks for sharing this inspiring lecture. The question is, are you also considering the implication of future climate, and will be this implemented into the tool? Yeah, so that's a question that perhaps Join also has in a bit. Yes.
Yeah, so that is actually, of course, something that is on our mind, and we have been considering different ways where this could be done. Is not yet part. I know that you, Emanuele, you have some thoughts on how this could be done, and I hope that in the near future this will be possible. But anyway, the tool allows you to analyze that there is the map that gives you access to those weather files. But if you have any EPW present or future that is valid in a valid format, that can also be analyzed. So if you have future weather files, and there are a few sources, and on the documentation we also point out to few sources where you can find those, that can be processed by the website.
Sure.
Okay.
Giovanni,
sorry.
very small. Yeah. Please, Emanuela, go on. Yes.
No, just staying the point that he just discussed. A question from the public. The public asks if the value can get also in numerical format.
There are a few ways in which that can happen. So you can download the APW, you can download the Clima data frame, and throughout the website there are a few tabular reports for specific variables. So I don't know exactly what numeric format the person is asking for, but we have a few.
Sure. Yes, let's say that the numeric format are more an input for the CB tool rather than an output.
But we try to give visibility to those with all those mouse over events. So we try to make it that it looks nice and engaging, also maybe for a non-specialist audience. But we're trying to give as much transparency to the data as possible.
Fantastic. Thank you so much, Giovanni. We have some question for Umberto Berardi. So the first question is if these charts and this BEM and microclimatic future prediction are really interesting. Have you already thought on how the built environment in Toronto will adapt to such changes?
Oh, well, this is a 1 million question. I mean, like, I don't know. There are a lot of actual issues. The challenge mainly these days has been infrastructure related, the capability to really heat and cool these buildings. We get 300,000 more people, per year. That is clearly unsustainable, but on the other side, it's happening. And so the reality is that modern adaptation is really a mitigation impact at the end of the day. Like, and we try to figure out a way to, power these buildings. And we make sure that, we can still try to kind of be sustainable in the sense of livable, or are we going to become a very, unlivable city? So there are different issues. 10 years ago, we worked a lot on greeneries. City of Toronto these days oblige all construction to have a green roof. There is basically significant increasing contribution due to renewable. Going back to the question we heard, we have been doing different multiple analysis of the impact of large adoption of PV at the city scale on the microclimate. So there are a couple of papers on sustainable cities and society, the journal, where you can find actually studies done at neighbors or at the entire city scale level, because the city was pushing, bigger demand, and 10%, 20% of roofs completely black, what is really impactful at the end of the day. So we have done something, but the topic is so big, nobody can handle, in isolation.
Okay, fantastic. Thank you so much. This very insightful answer, also with some reference, close the session. We remind that recording will be available next week. We also remind all the audience to keep posting their question for the next session. I leave now. Thank you so much, everyone. If you want to join, in case you have time later. Yes, hi everyone. In case whoever wants to join around 1 o'clock, we will have also a general discussion of about half an hour. Everyone is welcome. I leave now the word to Emanuela to kindly coordinate the next session.
So we now switch off to the next session. It's related with envelopes in light of climate change. And in this session, we start with Jesus Lizana. Jesus, if you are.
Yes. Can you hear me well?
Yes.
I need to be presenter in order to share my screen.
Yeah, I know. Okay. So please, Emily, can you? Okay, yes. That's it.
Can you see my full screen?
Yes, we can. Yes, go ahead.
Okay, fantastic. So hello everyone, and thank you for the invitation to this seminar. I am Jesus Lizana. I am an architect, a Marie Curie Research Fellow here at the University of Oxford. And in this presentation, I will introduce the work that we are doing looking at the role of citizens' data in order to create more accurate weather information to support the climate adaptation of our cities. This is a work that we are doing inside the framework of the Future Cooling program of the Oxford Martin School, in which our interdisciplinary team, we are working together to shape the future of cooling. In this program, where we try to answer, to provide answers to the following question: what can we do to mitigate the impact of heat? We are working at different action scales in order to understand much better the implication of global warming, to try to address the problem of the urban overheating and the building overheating, and how to address people discomfort more efficiently. This is really important, especially considering the last IPCC report, where we can see how the target of keeping the temperature increase below 1.5 degrees Celsius, something agreed by the Paris Agreement, is out of reach. Climate change is here. In all possible pathways, we know that we are going above 1.5 in the next decade or sooner. So we need to understand that we need to forget somehow about the historical weather observations that we commonly use to support building design, and start designing buildings in order to be prepared for the coming climate hazards. So this is the work that we are trying to look with to create with citizens' data. We try to create more accurate climate information to support the building design in order to understand much better what are the climate-related events that our cities are going to face, and try to find the interrelationship between these climate events where we have higher exposure in our cities and where we have the highest vulnerability to support the creation of much better adaptation policies. We are working with two main strategies. First one, working with citizen-driven distributed computing, and the second one with citizens' weather data. With the first one, what we try is to generate the highest spatio-temporal resolution climate modeling ever formed using the potential of the citizens' computer, in which we are able to share individual computational tasks into a large number of citizens' computers, in this case more than 30,000. With this, we are able to get climate simulations globally of the different climate change scenarios at a very high resolution globally. However, one of the main problems of these global modelings are that they overlook the urban overheating. So the data, the data to model the built environment at a very high resolution is quite challenging. So in order to understand much better the problem of the urban overheating, we are also looking at the citizens' weather data in order to get information at a much very high resolution, how are the weather conditions inside the city. This is the results that we can get from the first strategy with the citizens-driven computing, in which in this specific map, we can see we are using in this case cooling degree days as an indicator of the increase in cooling needs and heat exposure globally. In this case, from 1.5 to 2 degrees Celsius. This is interesting to see. The first thing that we can notice is how the countries with the highest increase in heat exposure from 1.5 to 2 degrees Celsius will be in the tropic, especially in Central Africa, in Southern Asia, and in South America. Even in Europe, we can see how the countries that will suffer the highest increase in cooling needs are those located in the Mediterranean area, especially in the southern Spain, Italy, and even the coastal area from Greece to Croatia. So it's really important to start designing buildings, understanding the implication of climate change and how we are going to change the weather conditions that our cities are going to face. However, as I said, one of the problems is that the increased heat exposure will be even higher in cities due to the problem of the urban overheating. And this is why we started to explore the potential of citizens' weather data, referring to data coming from sensors that we can install in our homes. For example, the sensor that you can see in the screens, and share this data publicly through different open access platforms such as Netatmo or Underground. We found that we have a meteorological network with citizens' data 12 times larger than the official meteorological weather network globally. And we can use this data to increase the resolution of and to understand much better what is happening with the urban overheating globally in whatever city around the world. So this is the kind of information that we can get, in this case, testing the tool specifically for the city of Seville, where using this freely available data, we are able to map and to understand where we have the hotspots in our cities in order to support the policy adaptation policies. And in order even to understand how we should design buildings in specific locations where we know that the heat exposure will be even higher. We can see, for example, here how at night in the city of Seville in Spain, we can find temperatures higher than 6 degrees Celsius in some urban areas. So with this work, what we try to highlight is the important role of citizens' data to support the generation of accurate weather information globally at macro and meso scales, and at local and micro scales. Or the next steps that we would like to achieve in the following months is to share, to disseminate, to close the different publications defining these approaches, to release the tools and the data generated in open access in order to support the decision-making process, in order to start designing and implementing better adaptation policies globally. This is the end of my presentation. Remember that you can follow us in our social media and even subscribe to the newsletter that we have in the Future of Cooling program in Oxford to keep updated about the work that we are doing here. Thank you very much.
Okay, thank you, Jesus, to be in time correctly. And it's really important the role of the citizen and have correct data. So maybe after in the panel we can discuss further. So the next speaker in this section is Miren Juaristi.
Hello.
Hi. Hello. The floor is yours.
Thank you so much. So I will talk more about technology in my session. I would like to present you the concept of adaptive opaque facades to shift from highly insulated envelopes to thermal modulators. This is a topic that I work on during my PhD and that I am now following as postdoctoral researcher in a project that I will show you in the end of this presentation. So so far, to have efficient energy buildings, we have been highly insulating them and improving the air tightness as much as possible so that we could minimize the heat losses to reduce mainly the heating energy demand. And this is something that already Andreas has presented in his first presentation and has also talk about how the internal heat gains can deal with it and how it can create even some moments of overheating. So this focus that we have had just about the U value of our envelopes is also creating some issues in certain climates, and we have been increasing even if reducing the heating energy demand, increasing the cooling energy need, even in climates where historically this was not needed. Besides, when proposing the insulation levels, the norms are considering average situations and specific weather files, which are, let's say, a static picture of it, when, well, not neither the internal situations are statics, internal heat gains are statics, neither the climate. And of course, we are not talking just about what happens from one day to the other or from one season to the other, but as we all know, the climate is changing, and therefore the insulation levels that we are putting today might not be the best ones for the future scenarios. So to face this sub-optimization of static building envelopes and high insulation levels, the concept of adaptive facades can be helpful as a response to this new need. And adaptive facades are the ones that can change their properties or behavior over the time according to the indoor needs and outside environmental conditions, and they do that autonomously. And thanks to that, we can bring back to the building envelope the role of modulating the energy exchange between indoor and outdoor environments. So we can decide when we block the energy flow and as a traditional highly insulated building can do, and when we enable the heat gains getting in or having heat dissipations through it. And of course, we can also decide when it's suitable to store the energy in our buildings. So adaptive facades in the transparent component is something that we have already seen built in different inspiring buildings. Autonomous shading system as the one in the center of the page is a reality now. It's a technology that you can apply. However, adaptive opaque facade components have not taken successfully the market. I will show you just a really few examples of technology concepts that have been studied mostly in the research environment and that can help you understanding how we could modulate the heat through the opaque part of the building envelopes. So one mechanism that we can use is the pressure difference between the indoor and outdoor environment. And we can achieve this thanks to the integration of forced ventilations through ventilators. And this is something that it's used in the concept called paretodynamic walls and permeodynamic walls. In the first one, what we basically have is a bypass, let's say, in the insulation layer, and therefore you can let the airflow go from one environment to the other when we actuate the ventilator. Instead of on the permeodynamic walls, you can let the air pass in through this difference in pressure thanks to the porosity of the material. Another mechanism that we can use that it's slightly different as the one of this dynamic insulation prototype of the University of Colorado is having mechanical actuators, so that in this case you see on white an insulation material that when it's like let's say a Venetian blind, and therefore when the material insulation is in contact, it acts as a regular insulation layer. When it's in parallel, of course the air flows, and therefore the insulation level drastically drops. So this would be these three concepts show us how we can go from highly insulated to low insulated building envelopes. Another aspect that we can control in our opaque parts of the facades is the temperature that we reach in the outer cladding. And here during my PhD, I proposed the concept of regulating this by changing the material configuration. So we have two materials of different reflectance, and therefore depending on which one is the most exposed one to the exterior, we can modulate the temperature that we get in this outer cladding. So therefore, of course, we are changing the temperature gradient between the indoor and outdoor environment thanks to this control. And of course, this could be something also interesting to control, to reduce in certain moments the urban heat island effect. So I actually have an article in Build Up that you can read, and there we present a more technology concept, not just the ones that I briefly showed you today, and also their benefits and their drawbacks that of course might explain why they have not reached yet the market. And you might think that, well, some of the benefits that the adaptive opaque facades can have to optimize our the thermal behavior of our building could be reached with natural ventilation. However, this facade concept would perform better regarding the noise insulation and air pollution because you are not getting contact with the external air. It's also a better alternative to not just reduce the cooling energy demand, but also the heating demand. And so as we don't have these technologies in the market because of several aspects, we wrote a project to deal with it, and happily we won it, and you have it here, the name, and we are going to prototype a new robust facade technology concept, calculate its benefits, and if success, to plan its future market update. And you can
sure.
know more about it.
Thank you so much, Miriam. We pass to the next speaker, who is Ioannis Kousis from University of Perugia. Thank you so much. It was very interesting. We pick up the topic later.
Hello, everyone. Do I have access to the slides of the presentation? Okay.
Yes, you should click on the monitor and you would be able to move it.
Okay, so here at the I work at the Environmental and Applied Physics Laboratory of the University of Perugia, and we take always in consideration the urban environment holistically by following typically systems thinking approaches for environmental monitoring with the various environmental monitoring techniques. So what we do is that we consider urban environments as complex living organisms, and we investigate them accordingly by taking into account pretty much all the main boundary parameters that affect their quality, both in the indoors and outdoors. So actually, we put a great effort to an intra-urban evaluation of cities by applying a wide monitoring network that comprises a variety of stations that can be both mobile or fixed. So in the very end, we additionally take always into account the citizen's perspective, and we apply participatory approaches by integrating also social sciences in our research. And we practically always aim to actively involve citizens in our monitoring campaigns and further engage them with our relevant activities. So we have developed a series of relatively low-cost stations that can be applied within almost any urban area. It can monitor simultaneously urban environmental domains such as the thermal environment, air quality, noise, and lighting levels. So here you can see some examples of these stations that include monitoring stations that can be placed at top of cars or lightweight sensors that are made with 3D printing and can be placed at top of bicycle hats, backpacks, strollers, and drones, and other similar carriers. So what we do is that we go inside cities and perform various monitoring campaigns. We have developed and published several specific monitoring protocols for identifying ideal days of monitoring with respect to the local microclimate boundaries, protocols for post-processing of the data that we collect, and their consequent analysis process. So what we obtain we can obtain in the very end is a very good representation of the environment of the city with high granularity. So essentially, we can locate hotspots of the investigated parameters, and together with the local authorities or decision makers, we propose mitigation solutions when they are necessary. So in the very end, what we envision is a big network comprising not only monitoring stations across the city, but the real-time participation of citizens and decision makers that will eventually result not only to provide real-time information, but will also forecast the trends of various environmental parameters within each city area. So what we aim is to a highly efficient real-time urban resiliency against climate change at a city scale through a detailed monitoring network. However, we do not have the illusion that urban resiliency will be achieved just by monitoring urban parameters. The understanding we know by experience should be coupled with the active actions such as the application of smart material-based solutions for the mitigation of various issues affecting cities' quality, and one of them is the urban overheating. So we know very well that mitigating urban overheating is almost a necessity for several cities around the world. Every year we experience all the more higher urban surfaces, higher urban temperatures that results in several heat stresses incidences and serious issues related to health and well-being of the citizens. So until recently, several types of material have been proposed as materials that can reject heat and can improve both indoor and outdoor environment. They can be placed on roofs or facades of buildings or on pavements and decrease the surface temperature of these surfaces, or at the same time decrease the air temperature above them and therefore mitigate high urban air temperatures. So typically the main asset of these solutions that are also called cool materials is the high reflectance of the solar radiation, which is simply words is like the reason that we will choose to wear a white t-shirt instead of a black one if we want to go for a walk outside in a sunny summer morning, because we know very well that the lighter is the color of the surface or of the t-shirt, then the higher will be the solar reflectance, so the better we will feel with a lower surface temperature. But the main turning point of materials that reject heat took place in 2014 with the introduction of the daytime radiative coolers that were reported and experimentally tested for the first time to achieve sub-ambient temperature. That means that the surface temperature below the air temperature above them under direct sunlight in a summer day. So what daytime radiative cooling actually does, it is that apart from the solar reflection, takes also into account the emissivity of the material as a heat rejection mechanism. So we have a double-fold heat rejection mechanism. So these materials highly reflect the incident light up to more than 95% of the incident light can be reflected by daytime radiative coolers, while at the same time they highly emit thermal radiation, specifically within the atmospheric window. Atmospheric window is a wave range from 8 to 13 micrometers, in which Earth's atmosphere is almost completely transparent to the long wave radiation. So what does that practically mean is that if you specifically emit within this wavelength, then you send directly thermal radiation to the outer space without interfering with the Earth's atmosphere. So this is actually pretty cool, both metaphorically and practically, and several research groups have demonstrated experimentally sub-ambient temperatures within the last decade. So here at the University of Perugia, we are very happy and proud to work with this type of materials, thanks to an ERC project that has been won by Professor Anna Laura Pisello. So we work on the development and the test of daytime radiative coolers in our laboratories, but also in specific design fields that we have developed here at the University of Perugia. But what we do as well is to investigate their performance at bigger scales, at the building, neighborhood, and city scale, by collaborating with also with Dr. Alberto Martilli of CIEMAT. So what we do is that we have introduced for the first time the optical properties of daytime radiative coolers into a detailed urban canopy model coupled with the WRF, and we saw for the first time that different types of daytime radiative coolers can actually decrease surface temperatures of buildings in cities, as well as the air temperature above them, and we have applied these cases for different scenarios for different cities around the globe, and in most of the cases we have some really good and promising results. And so to conclude, some key messages is that yes, we believe in a detailed intra-urban evaluation of urban environment by simultaneously monitoring interrelated domains. We believe that human-centered approaches are pivotal for engaging citizens. We have to understand the specific cities that we choose to investigate with specific microclimatic boundaries and be smart, use smart materials like radiated cooling materials that seem to be a very good promising
Sorry,
opportunity
Yannis,
for.
I have to stop you.
Thank
So sorry. Thank you very much for your
you.
interesting presentation. So we can pass to the next speakers. That is Alessandro Cannavale. Is Alessandro there? Okay. Hi, Alessandro.
Can I have the possibility to control the progression of the slides?
Yes, if you click in the middle of the screen with the mouse, I think you can.
I'm trying.
Yeah, give me one moment.
Yeah.
One moment.
No. So if you can do it for me, it's just the same.
Okay, the floor is yours.
Okay, probably now I can. Okay. So I can control the slides. Thank you very much for this invitation and the possibility to share some considerations about the role of chromogenics in the energy transition. New regulations, as we all know, require higher standards for indoor illuminance, but also require effective shading strategies. And indoor visual comfort and energy saving are some way interconnected in the roadmap towards the energy transition. And I strongly believe that chromogenic technologies could play an important role in responding with innovative solutions to these multiple needs. We all know that chromogenic materials and technologies are mainly subdivided in some classes like electrochromics, photochromics, or thermochromics, according to the physical stimulus that activates their optical modulation. But the most important thing is that we can dynamically change the optical and thermal properties of glazing some way. So let me show you some recent results deriving from my personal commitment in the design of novel architectural devices, novel architectures for devices, for chromogenic devices, at least since 2009. These slides contain some data about a recent electrochromic device that I have designed, fabricated, and studied in the laboratories of CNR in Lecce and Politecnico di Bari. And as you can see, we have a very simple architecture. So the objective is to design low-cost electrochromic devices for smart windows. I have shared some figures of merit in terms of reflectance and transmittance. And what I want to show you is that we have a solid-state device on a single substrate that can be glass or plastic, so flexible substrates, and we can obtain a fair modulation of about 35% of solarity gain control, but also a surface that is fairly low emissive. So these kind of devices can be used, okay, as a film with a thickness of lower than 10 microns, as you can see in this cross section taken with an SCM microscope, and can work effectively as a solar control and selective film on phase 2 of glazing. These are some prototypes that I have fabricated. This interesting timeline that has been published by the group of Professor Lefteriotis in this work by George Sirokostas shows the timeline of research activities dealing with photoelectrochromic devices dating back to the seminal paper by Beckinger published on Nature in 1996. And in this long review of this timeline, I have highlighted in red some works that I have deriving from my personal commitment in the design of new devices, working as photoelectrochromic devices, so they can change and modulate their optical and thermal properties according to the available solar irradiance, but also capable of producing electric energy by photovoltaic conversion. So not only photoelectrochromic devices, but also photovoltaic devices. In these activities, I had the possibility to collaborate with great groups, such like the one led by Professor Henry Snaith in Oxford. Another interesting technology to increase the adaptivity with the intrinsic adaptivity of transparent building envelopes is, of course, represented by photochromics. And in collaboration with the University of Perugia, we have investigated the effect of building integration of spiroxazine-based photochromic materials in buildings using using the Energy Plus software platform in order to obtain interesting feedbacks for chemists and materials engineers who design and produce such molecules, shifting from one isomer to the other, in order to try to obtain some materials that have intrinsic intelligence, and so in order to find out the way to reduce costs for building integration of these innovative technologies. This molecule, even though it shows a very narrow band absorption spectrum, it even reported interesting results in terms of UDI and daylight glare probability reduction. The last technology that I want to show today is this highly transparent perovskite-based photovoltaic device that was produced in the University of Oxford. I had the possibility to collaborate with them in order to study building integration of such neutral colored, highly transparent micro island perovskites in buildings, and the result was very interesting also in this case, because this kind of technology had two important effects. On one side, the optical properties of this spectrum are comparable with commercial solar control films sold by important companies worldwide. So we had very good results in terms of daylighting control, but also we had the possibility at the latitude of southern Italy to produce electric energy with a yield, very interesting yield, and so we had the possibility, the chance to produce as much energy as to cover to complete reach the amount of energy expenditures for artificial lighting in a year time. So I have concluded my presentation, and I thank you again for this invitation.
Okay, thank you, Alessandro. Just in time, it's okay. So now we have the last speaking of this session, that is Fabio Favoino. Fabio, nice to meet you. And so,
hello, good morning everyone. Yeah. Can you hear me well?
More or less, yes, a little bit echo in the, yeah.
Okay.
Now it could be better, I think.
Okay, good.
Okay, better. So,
okay.
The floor is yours. Go ahead.
Thank you, Emanuela and Emanuele, for this kind invitation. And today I'm here, like representing the little bit the TEBE, so Technology, Energy, and Building and Environment Research Group, and particularly the part of the group that is working on building envelopes and in general of envelopes of building, but also applied to other sector, what we call also special environments. It could be car, boats, so enclosure in general. We have quite let's say a big staff that's dedicated to it. So to mention, let's say the more permanent staff is Professor Perino, Professor Serra, myself, and Stefano Fantucci, where the teams we are really looking at. So our main research area and focus is really the development and characterization and looking at the building integration of innovative building envelope technologies. Mainly in the years we have developed a little bit of experience for responsive and adaptive, the transparent and opaque facades, then vegetated envelopes, working a lot on super insulation as well, and the integration of facades with the HVAC systems and renewable energy sources. Our approach is really both being able to measure on one side experimentally and simulate the impact of these innovative technologies on the energy use in buildings, and more importantly on indoor environmental quality aspects, mainly thermal and daylight comfort in the perimeter zone, and looking at controls of say dynamic elements. As you've seen from the past presentation of Alessandro, such dynamic technologies, they are able to manage somehow solar radiation and other heat transfer mechanisms. So they rely really on a control system to do that. So we're very focused on designing this control system as well. And this is the examples that I'm bringing to you today. To basically support this both simulation and experimental work, we have created in the years quite a large experimental setting, going from, let's say, low technology readiness level, so at the material characterization scale in the lab, to different outdoor and indoor test facilities in which we test the performance of facade building envelope components, and small labs that are basically supporting in creating, let's say, sensing and controls devices up to the level. So what we are building now is really the level of demonstration of this technology into real life. One of these test facilities is the one that will basically will present more in depth today, is the Twins test facility, so testing window innovative system test facility, where we recently upgraded. So we have basically two comparable non-calorimetric, so absolute passive cell with then a small baby of the Twins, and where we can test basically different building envelopes on the south facades. But what we did in this, well, actually during the pandemics, is that we transferred all these physical environments to its digital twins, in which we are able to basically do a real-time visualization of the data, but also real-time control of what's happening in the environment and in the facades that we are testing. In this test facility, during the years, we developed a lot of experience on mainly transparent systems. So on the top, on one side, double skin and advanced integrated facades. So there are also a level of integration of renewable energy sources and integration with the HVAC system. And at the bottom, experience in really controlling and optimizing the control of smart glazing. So basically, this experience we developed let's say we are convinced, and we see the building envelope not just basically a passive way to manage heat transfer to the aim of improving indoor environmental quality, but really we see it as a heat and mass regulator of the indoor environments. And this is particularly important when we think about building a building today and operating it for maybe the next 60 years in a way that our boundary conditions are actually changing. So we need to adapt also the way we manage that heat transfer and we regulate the indoor environment. So really the next slide, just to introduce a little bit this concept on a typical transparent system. So if we take, for example, just a double glazing unit with an outer shading device, and we try to put on a graph the amount of heat flow that is going through the glazing, and on the y-axis, the amount of, let's say, daylights that can go through that surface in terms of illuminance, and we change the boundary condition next to it, what will happen is that we are able to manage in a way both the amount of energy, total energy that goes through the system, but also the amount of daylight and how we are impacting on the indoor environment. So here we changed, for example, in steps of 200 watt per square meter solar irradiation on the outside, and the delta T of each step of 5 degrees C. Now, if we instead try to do it using also ventilation in a cavity, so a double skin facade, we extended this concept to a project where that's mainly sponsored by a Norwegian Research Council. So it was done together with NTNU, Vicona, part of Hydro, us, and Aalto University. We try to bring this concept to an extreme, so to see how much flexible we are in managing the overall heat flow across and daylight across the facade. In a double skin facade, we can do it by changing the ventilation mode, so whether we take air from the inside and bring it to the outside, or reversely, or we close everything in thermal buffer mode, or we take the air from the outside and bring it to the outside, or vice versa, inside to inside, and the way we manage also the internal blinds, and if this ventilation is mechanically or naturally driven. Okay, so by redoing this exercise for a double skin facade that is highly flexible, so that it can achieve all these different ventilation modes naturally, mechanically, and also operating the blind, we can see that by changing the boundary conditions, so 200 watt per square meter radiation step and 5 degrees C steps, we can see how much we are affecting the heat flow through the facades and the daylight through it. So if we finally compare what we did before, so a double or a triple glazing unit, with the domain in which we are affecting heat transfer to a double skin facade in the different ventilation modes, you can see that with such a highly flexible facade, we are really able to use it as an inter-mass transfer regulator of the indoor environment compared to a triple glazing. So in a way, and this depends really on the ventilation mode. So really the question is, how are we able to control such flexibility once we are able to achieve it? So what we did in a framework of a PhD program, we basically tried to understand how to control these different 70 configurations possible at each time step of the facade. First, to be able to model it correctly, and then by means of control, taking basically a control approach that's rather, sorry, I'm not able to change slides.
Yeah.
Sorry. Okay.
Fabio, sorry, I have to stop you. You are left your 10 minutes. So,
Okay.
Okay, now we have ending this session. So I ask all the speakers to switch off the camera and we start the discussion and question from the audience.
Yes. Yes. So it was a very interesting session, perhaps the most technical up to now. We had several data and several technologies. Also, in many cases, we have seen a very interesting digital twin. With Jesus, we emphasize the importance of collecting data and to cross-reference those according to dynamics of climate change. That's super interesting type of research. Then with Miran, we had the chance to think of the next generation of opaque type of envelopes. Very critical will be to understand how these opaque envelopes that are static by nature will adapt to climate change. Following, we had very interesting set of site technology for measurements by Ioannis, who also integrated very interesting diagrams on how material characterization, reflectivity and emissivity should be played locally and according to wavelength. So probably we will have a few questions on that also. Thanks, Alessandro Cannavale, for sharing your insights and how your work fits into the history of how dynamic sort of material evolves. Will be also interesting later. I will have a question on how what's the next stage in this timeline. And finally, we had a super interesting contribution from Fabio that shows some example and also the brilliant facilities at Polytechnic of Torino. Perhaps we can start with a bit of a randomized set of questions. We will not follow the order of the presentation, but we have a question for everyone, and we start with Emanuela posing some questions.
Yes, we are collecting some questions, for example, for Jesus. Jesus, how do you choose or how do you identify urban area in your study? I mean, what is the index, or what is the your preferred, I don't know, yeah, what is the index that you use to choose your urban area in your study?
In this case, where we are using this data, using citizens' weather data, we can get very high resolution of the climate in the urban environment in order to identify the hot spots where we need to prioritize actions into the cities. We are using cooling degree hours. This is the indicator that we are exploring to identify the permanent hotspots in the cities. Since the urban heat island effect is not permanent, it's not the same over time. It's changing according to the different weather conditions. And with cooling degree hours, according to the whole summer season, we can identify these persistent hot areas.
Sure. I also have another question from the audience, which is collecting data from citizen. What is factually adding to recorded conventional recorded data?
In this case, I mean the value is the high density observation that we can have in cities. Common weather data that we can find from the presentations are coming from weather stations, most of the time located in rural or suburban areas, and they are not representative of the weather conditions in the built environment anymore. So with this kind of information, we can get really accurate weather information about what's happening inside the city, in the built environment. And this is a key point in order to be able to design buildings more efficiently.
Thank you, Jesus, and congratulations for your brilliant outlooks. Yes, Emanuela, other questions?
Yes, I collect one question for Miran, for example, and the question is related with typology of facade, and say, in your experience, what is the more effective strategy to use, mechanical strategy or changing material?
Well, I would say that to answer to that question, we should prototype each of these typologies and to do several tests, which unfortunately is not the current status of most of these technologies. So yeah, I think that experimental tests need to answer that.
Sure. Perhaps I will add to this question, Miran. We know that buildings tend to overheat. We know that the concept of passive house with no fence of German type lead to rethink the role of opaque envelopes. What is your trajectory of research to think of opaque facades that are better calibrated according to a changing climate context?
I don't know if I understood your question. I'm sorry.
Sure. With the overheating of buildings,
yeah,
especially those that are highly insulated or where they have insulation according to European Community. How do you see evolving the concept of opaque envelope in order to cope with the stresses, especially the summer stresses given by climate change?
So for the ones that are already highly insulated, you mean? Or for the new one, for the new strategies? Because for me, the answer for the ones that are not yet highly insulated, so we have many buildings to refurbish, or the new ones that we will do, I really hope to deliver a technology concept that can shift from highly insulated levels to low ones, so that we can control, as Fabio has exposed in his presentation, also the level of thermal flow in the opaque part, not just in the transparent, because during my research I could see that the transparent part of the envelope is being studied much more, and they are doing many advances, and they are reaching to control their behavior to optimize it a lot. So I hope to deliver a technology that it's going to be similar, but just for the opaque part, so that the full envelope is optimized, not just the transparent part. I don't know if this answers your question.
Yes, it answers. Probably thinking of material that have not seasonal penalties would be the future. So congrats on this direction. I'll leave the word to Emanuela for further questions.
Thank you. And I have a question now for Ioannis. Ioannis, how do you take into account the building constructive component in your model related with the optical study? You say that you develop a model with, for example, Alberto Martilli. I know the work of Alberto Martilli, and I would like to know how do you take into account the technical part of the model of the building in your model. What is the component, or how do you take into account the component of the model of the building?
Okay, so yes, the urban canopy model includes the characteristics of the building envelope, and you can actually adjust them as you want, so as to investigate different architectural contexts. So you can modify as you wish the height of the building, you can modify the number of the floors, the width of the building, also the width of the street, so as to create the corresponding ratio between the street and the building. And you can also go inside the code and, as we did, and introduce the optical properties that will eventually regulate the thermal properties of the building. So you can play with the reflectivity, with the viscosity, and the transparency of the materials that you want to investigate. So it depends on what type of material you want to investigate in the very end and to understand its optical properties.
Mm-hmm.
Okay, very great question. Very great point. I have a question for you, Ioannis. People were very interested in your chart where you were expressing power or potential for reflectivity and emissivity, and some paid attention to a fluorescent material description, which seems to be a sort of a magic material. What are the properties of fluorescent material, and why would be interesting for the built environment? That's the question.
I'm not sure I understood for which slide you mentioned. The one with the fluorescent.
Yeah, perhaps you can refer to that. Yeah, by voice. Yeah.
Okay.
If you can elaborate a bit more about fluorescent material. Yes, please.
In any case, both fluorescence and phosphorescence, so that means photoluminescent properties, are a good seem to be a very good solution for applied to what we call cool materials that reject heat. Because typically these materials, as I said previously in my presentation, are light colored or white materials. So if we want to give them color, which is the case if we want to have a real life application of them, so if we want to give them color, we have to somehow we have to absorb visible radiation, so we will compromise the high solar reflection. Other photoluminescent materials have the property of absorbing into the visible spectrum and then remitting back into the near infrared. So they have what we call an effective solar reflectance, that it is a twofold mechanism, a heat rejection mechanism that includes both the classic reflection, but however the re-emission of the visible part into the near infrared region. So these materials can be used also for, have been used actually, for giving color to radiative coolers, the materials that I previously speak about, and are expected to be maybe the best solution for giving colors to cool surfaces for a built environment application.
There is a final question for you, Ioannis, which is about can this material give some glare issue?
Again, it depends on the color of the material that you are going to use, and again, it depends where you are going to apply them. Of course, if you want to apply them, if you want to apply a white color radiative cooler on, in any case, a white color cool material, and you are going to apply that on a central square of a city, yes, most probably you will give some glare issues on the pedestrians there. But if you want to apply them on the top of the roof of a building, then most probably you will not have this issue, except if you want to hang around on the roof of the building. So it depends on the application, and then it depends on the color. So that's when the photoluminescent materials come and can actually give the desired color without compromising the solar reflectors of the material.
Okay, thank you so very much, Ioannis. Very interesting research, and I'll leave the word to Emanuela.
Now I collect well, I want to ask to Fabio to tell us how they use this methodology control in the sense of simulation. How do you use the data that you recollect for the control in your simulation model? Because we stop you, so I think.
No, that's okay. Fine. Absolutely. In the way we are controlling this regulator, it's a different control strategy. So rather than leaving everything to the BMS, so the building management system to do, means sensing, evaluating what's the effect of the control, and then implementing the control. For, let's say, facade integration, we are using a kind of decentralized control strategy, where we have realized a small IoT device that's embedded in the facades. And in the IoT device in itself, we are, by means of simulation, we are basically characterizing what's the amount of heat flow and of daylight that is going inside the room. So in a way, we are constraining the building management system, that then we provide this constraint of information to the building management system that comes back with optimized, let's say, heat flow that wants from the facade, and then the local decentralized controllers translates that into a combination of states of the facade that can give that. So this is a way that we found to deal with this complexity, so that we don't demand everything to the BMS, but actually we are able to translate the complexity of the facade to the BMS and translate back a requirement of the BMS to a complex way to actuate it on the facade level. And this is an approach that we think it's first of all low cost, and then it's highly scalable on, for example, different parts of the building, different facade and orientation.
So you think that it could be also useful for the opaque facade, as we were speaking before with Miren, that it's focusing on opaque facade, adaptive opaque facade?
Yeah, I would say that whenever we go in the direction of controlling heat and mass transfer through the envelope, and we want to do it in an active way, going for decentralized control, that's a way to deal with high complexity of how we actuate that on the facade. So finally, it depends on how the opaque facades will, or the technology, specific technology will deal with this complexity. But for sure, this can be a good approach for the control, I would say.
Well, thank you very much. So, Emanuele, do you have any other questions?
Yes, for Alessandro. Thanks for joining. Thanks, by the way, Fabio, for your interesting insights. Alessandro, you have been in the field since early stages, although you're young. I wanted to ask, what are the future line of the future trajectories for dynamic chemical based types of facades, and also we could register. And the second part of the question is that this technology, despite an intensive research, haven't been yet largely applied. What are the triggers of, or what are the obstacles within this process? Thanks so much.
Thank you so much, Emanuele, for this question, because it gives me the chance to speak about these important points. Anyway, studying the lessons learned from the evolution of these technologies, especially photoelectrochromics and electrochromics, we can find out that the evolution of materials available in the last years, in the last decades, I'd say, has triggered the evolution of devices mainly. So materials, investigations about materials and further investigations about materials will be fundamental, I'd say, because if we have good materials, we can design novel devices. So a few years ago, probably I couldn't have shown the slide with a solid state, one single substrate electrochromic device. So this is the effect of a strong investigation about materials, novel materials. I think that cross-disciplinary research is fundamental also because we need more awareness about the expectations of performance, regulations, and so on about materials that are created in the laboratories. So I think that the strong interaction between engineers, architects, designers, and chemists, for instance, is fundamental because everybody should be aware about the expectations we have for new materials to be used in the urban environment.
Yeah, fantastic. That's really a good closure to the session. Looks like you have a fun job ahead with the interdisciplinary teams. So good luck. We will try to follow your production with extreme interest. So thank you to all the panelists. That was one of the largest session and one of the most technical. And now we try to soften a little bit the topic in about actually 12 minutes. So we are able to take a 12 minutes break. But let us announce the next session, which will be more talking about the living systems. And now these are considered or begin to be considered as a material, as a layer, and much more than a layer, given all the co-benefits of such solution in light of climate change. So we will have Roberta Coce-Grifoni from University of Camerino, Katia Perini from University of Genoa, and then Maria Beatrice Andreucci from La Sapienza. So we meet at 12:20, and thanks for being with us. Also, small comments, feel free to continue while speakers are sharing the points. Please keep writing your question to the chat. These are very important for the moderation of it. Emanuela, would you like to add something?
No, it's okay. So see you later.
See you
Bye.
later. Ciao. Okay, so welcome everyone to this final part of the workshop, and we please ask our next speaker to be online. Again, a reminder for everyone who is connected to please fulfill the chat with your question. So we are very delighted to host the session named Nature-Based Envelopes for Climate Change. And we will have Roberta Coggi Grifoni, Katia Perini, and Maria Beatrice Andreucci. We start from Roberta. Thanks for joining us. And the floor is yours. You have about 10 minutes.
Thank you, Emanuele. Thank you, Emanuela, for the kind invitation. I'm so happy to be here and for the opportunity to sharing some consideration about the presentation. Can you, I don't know, okay, I think that I can control. Okay, I talk about green envelopes as a microclimatic boundary conditions and to focus attention to a peculiar mathematical issue, the boundary condition of heat transfer equation, and from my point of view, can be considered a very important aspect. Just a couple of words in introducing myself. I am a physicist and I have a master's degree in theoretical physics and a PhD in applied physics. So the double side of the same coin, but I think that this is a complex effect to support architects and engineers. I have been working from 2004 with so close to the architects, and so I try to support them in sustainable planning and designing. So I would start with the 8-minute agenda, and so I'm talking about nature as a design material that I consider very important aspect, and after green envelopes and boundary condition, as I said before, moving to parametric optimization, and after microforestation as an environmental acupuncture. We did remind, just let me remind that we are part of the nature, and so this is an ancient but new for me paradigm that I would like to propose, because I think that we don't forget that we are part of the nature, and also the green mind theory that suggests to link the human mind to the brain, the body, and to connect the body to natural and social environment. And this process, I think that is reciprocal. So environment shapes our brain and minds. The minds modify the behavior of the body and shapes the external environment. So in agreement with this premise, I would like to move on to define the boundary condition. And so we can consider boundary condition and the constraints that are necessary for the solution of the boundary value problem. So in mathematics, value boundary problem is a differential equation. So I think that is considered as a complex system to be solved in a domain on which the boundary set of conditions is known. So we can see that there are some aspects on the left side for the mathematical aspect, but on the right side, as the space can be considered in a project, a sub-public space and intimate space and so on. And all these can be considered as a control volume. So we decide to consider the vertical green system as a boundary condition and as an homogeneous layer. There are a lot of studies that consider this, and with some apparent thermophysical properties. So you can see on the left that we are the vertical grid system, the air gap, and after the building envelope. This is a complex system, but on the right we can consider it as a homogeneous layer, and so the vertical green system can be defined as a boundary condition for our building. Starting from these issues, we developed the green facade optimization methodology that study what is an efficient conditions for the green wall facade, and we decided to study using parametric optimization, starting from the weather data and moving through the bug energy plus and the plugin of the grasshopper to optimize the green facade with Galapagos. What we found is that inefficient insulation is up to 9 centimeters of the up to 9 centimeters, because more insulation became redundant and inefficient, because the green facade, you can see, has the same thermal behavior regardless of the boundary condition and the external condition. We studied in the Mediterranean area, and so specific climate condition. Another aspect, is a parametric, optimization, and so we decided to emphasize the link between comfort conditions in the outdoor environment and the efficiency of the building. I don't want to bore you, but we define a lot of correlation between all the meteorological variables and the thermodynamical variables, and with energy consumption and comfort expressed by predicted mean vote or UTCI. And what we found is defining 3 index, the capacity of the building. The second one is related to the energy consumption, and the third one to the building energy loss of the solar energy. And using a parametric simulation with a genetic algorithm that called NGSA2, and using a model frontier that we have stolen from the finances assessment, we found that the temperature can be considered the leader variable, and that for temperature greater than 33 Celsius degree for some indicator, or greater than up to 28 Celsius degree, we don't have a solution. So we cannot reach a good energy efficiency and also a comfort, an outdoor comfort. So how can we consider, and we can use all these uses in the project? We can use green devices as boundary limits in vertical or horizontal systems. We diffuse all these little green spot in the city. We start, the first step is the microclimate assessment. The second one is the TENS analysis. This is an acronym for thermodynamic environmental section. So in this case, you can see the main orthogonal road axis and the section for the environmental aspect. And some example of the city where I live, and that can be considered a case study for a lot of our research, is, for example, the City Leaf project, where we consider a lot of green devices and wall green devices to enhance the comfort outdoor. As you can see in the dot, we have an improving of the comfort, but also in the air quality and in natural ventilation. And this can be reached using in a very attention way the green system and environmental condition. The second one is the green transparencies. This is a project in a courtyard, typical in Ascoli Piceno, as well as in the little inland and medieval city. And we consider a sequence of some modules that invades the courtyard and can be considered the boundary layer as slicing the spaces. And these are the results. You can see that we have an improvement in the comfort. This is the map of the UTCI, and in the ante-operam and the post-operam on the left and on the right respectively. And in this section, I think that it can be considered the value of this project and lowering of the temperature and improving of the UTCI and so the comfort perception. So in conclusion, these issues were the basis for the European and national research programs. We are working on two LIFE, on the coastal LIFE AgriNet, and inland area, Life Imagine, some Erasmus Plus, Click and Eduscape, and some regional research and or national research as a PNR Research and Innovation, Vitality and PINQUA. Thank you so much. I'm finished.
Thank you, Roberta, to be in time. Then we step to Katia Perini.
Okay, so thank you. Do you hear me well? Okay. So good afternoon. Thanks a lot to Emanuela and Emanuele for organizing this event and for the invitation. I'm very happy to be here today. So I'm presenting the ECOLOPS project, the multi-species building envelopes. ECOLOPS is an H2020 project, Future Emerging Technology Open project, founded in 2021. So we have been working on this project for the last 2 years. So we are now in the middle of the path. So I will start with some background very briefly. So current urban greening is related to different scales: building scale, district scale, and urban scale, and with a range of MBSs, which are characterized by different performances. The performances are currently mainly assessed in terms of water management, thermal performances, which is so very interesting examples about optimization and monitoring of thermal performances, and in very few cases also in terms of biodiversity increase. So why should we increase urban biodiversity through different scales and topologies of greening? Nature, first of all, is fundamental for human well-being, and all the ecosystem services like the provision of food, clean air and water, resources like wood or medicine can only be provided by healthy ecosystem, and they play a crucial role in supporting local livelihoods. Biodiversity in city is actually quite high, differently from what we all think. but is decreasing a lot due to urban densification. Although we know that urban densification has several advantages, so I'm not saying that this is not advisable, but I'm saying that we really need to place attention and to consider how we design our building envelopes in order to support biodiversity. In Ecolops, we go beyond actually the ecosystem services perspective, which can be seen as a human-centered perspective in a way. So we propose a data-driven design tool to assist architects and planners in the design of Ecolops. Ecolops can be defined as a multi-species living space for 4 types of inhabitants: humans, of course, but also plants, animals, and microbiota. Plants and animals are fundamental for healthy ecosystems and biodiversity, and microbiota plays a key role also for human well-being. For example, studies show that rates of allergies are increasing in cities, and that, for example, children living in farms have much less problems with allergies. So this is also a health-related issue. Sorry. Our perspective is therefore a non-human perspective. And we aim to go beyond the design of a simple, let's say, green roof or a green facade to allow architects, engineers, and to design an ecological envelope, which can be seen as a dynamic living space for the different stakeholders that I was mentioning before. Ecolops is a highly interdisciplinary project. We have scientists, and not only, also companies, from physical science and engineering, life science, and social sciences and humanities, and also, as I was mentioning, 2 different companies. So we have the Vienna, we have Technion from Israel, University of Genova, which is us. We have McNeil, which is in charge of the software development and system of architecture development. We have the Studio Animated Design and the Technical University of Munich, which is also the leader partner of this project. Okay, so this diagram is a bit complex to be just seen in 1 or 2 minutes, but I will try to explain what we mean, what we aim to explain while we design actually this diagram. So it shows abiotic and biotic components which are considered in the design process, again, where humans, plants, and animal and microbiota act as inhabitants. And it shows also the set of dynamic impacts and relations among them. So animals, for example, with impacts on human well-being, seed dispersal, pollination, nutrients input, and also on microbial dispersal. The relations among the inhabitants can change over time, depending on the building material and the design, depending also on abiotic condition and on the dynamic of biotic components and the degree of connectivity between the building and the surrounding environment, and also the type and level of human intervention. Going a bit more into detail, okay. This is a workflow. So a design workflow means a workflow seen from the perspective of the design of the designer. So we have what is actually new from regular, let's say, in a way, workflow is that we have the ecologies, which will are involved from the beginning of the process. So they will represent the need of the non-human stakeholder or inhabitants, and along with the human stakeholder, which is represented by the client. Architects will define objectives, will draft possible design proposal or sketches for a design process which is based on iteration. Expert contribution is fundamental because they will use models and simulations to will suggest design solutions and provide feedback. And now I'm showing a simplified version of the computational framework. So we have a number of variables and data which are used for the design. They both come from expert and from open databases. In expert database are the ones that we generate within the project, actually. So we're not generating a huge amount of data to create this database. This data will feed the ecological model. The models are created by Ecolab's information model ontology, which collects also 3D voxel data. We have then the architectural design, which is generated. We simulate the performances of it, and we optimize and rank design outputs depending on the key performance indicators, which are selected according to the design objectives that we, in the first step, have to identify, and depending on their thresholds, which of course have to be site specific and will have to depend on the project. The ecological models are fundamental to drive the design from an ecological perspective. These are animal, plant, soil, and microbiota model. And they all identify which plants, animals, functional groups could reach an ecolab, depending, for example, on the soil type and depth and on the building geometry. So the ecological models are integrated within the environmental models. So this is a part that we are mostly work on for the from the University of Genova. And this is an example of one of the environmental models that we are developing, the solar radiation model. So we use the EPW file as input, and as an output we get a TXT file, which is used by the local ecological model to evaluate, according to the outputs, which plants, animals, and microbiota species will likely reach the ecolabs. So this integration is very important for the project, and of course is related to the building geometry. Here you just see a very simple example of a building geometry. So we are now in the second year of the project, and we are identifying the methodology to analyze the trade-offs and synergies among the inhabitants, and to validate the design process and the design outcomes. So this is the challenge that we are actually facing right now. And we'll then use our design platform to produce some design outcomes, which will afterwards validated and assessed according to some indicators of success for the real-world realization of building designed using our algorithms. Okay, so thank you very much for the attention. I hope I was on time. I think so.
Yes, perfect in time. So the last speakers of this session is Maria Beatrice Andreucci. Are you there? Nice
Thank you very much. Thanks a lot, Emanuele and Emanuele. Great to be here with you today.
Welcome. So thanks for joining.
Thank you. Thanks a lot. So I want to see whether I can change the slide. No? Okay. Yeah.
Yes.
No. Yes. Apologies. Thank you. Okay, with the steadily increasing world population and economic development, human pressure on freshwater resources is increasing, as is human exposure to weather-related extremes, droughts, storms, and floods caused by climate change. But it's not only the hydrosphere that has impacted us, as vice versa, it is likely that human activities have influenced the global water cycles since the mid-20th century. The demand for water is expected to increase by 55% by 2050, which will lead to a rise in water pollution, aggravating problems associated with water scarcity, since water availability is compromised by its quality. It takes a little bit of time to change the slide.
Yes, normally yes, but not so. Okay.
Okay. The restoration and maintenance of the water cycle, as well as the treatment, recovery, and reuse, are among the greatest challenges of the urban built environment. Water in the city is typically exploited in a linear process in which most of it is polluted, sent away for chemical treatment, and finally discharged. During this process, precious resources are lost instead of being captured and cycled back. Stormwater management is another example of non-sustainable linear water process, as typically its main goal is the fast discharge of stormwater to avoid flooding. With changes in climate, however, rainfall patterns can exceed the capacity of the sewer system and cause widespread flooding. Under dry condition, however, in which water would be needed to irrigate and sustain vegetation to maintain its necessary cooling function, water is once again used linearly, with fresh drinking water exploited as no other sources is stored or provided. Don't know, I try to change, but it's very slow, maybe. Okay. The circular economy model, or circularity, has emerged from multiple schools of thought and is much broader in ambition than mere material reuse and high-value recycling. The circular economy outlines an industrial economy that is restorative by intention, aims to rely on renewable resources, minimizes traps and eliminates the use of toxic chemicals, and eradicates waste through careful design. Within the concept of circularity also lies a high-level material reuse strategy with several actions that are already commonplace today. In this sense, nature-based solutions as green technologies that can be implemented in combination with existing infrastructure or as a standalone systems can support the transition toward the new water reuse paradigm by integrating circular economy principle into urban water management. The built environment can be identified as a key facilitator to address, promote, and benefit from a change in the water use paradigm by using the urban circularity challenges to shift towards a circular management of resources. At the building system level, water streams, including separated wastewater, precipitation, and runoff, can be reused on site using nature-based solutions such as vertical greening systems and green roofs that can be integrated in the building envelope in new and existing buildings in order to address urban circularity challenges. Plant water needs must be met throughout the year to allow for the full spectrum of multifunctionality that is increasing biodiversity, contributing toward public health, decreasing air pollution, biophilia, and cooling the surrounding area. This demand is mainly met with fresh water or drinking water, further contributing to water depletion. Moreover, the production chains of components for vertical green systems and green roofs not only consume water, but the production of this water requires energy for pumping and also for treatment, meaning the carbon emissions are associated with constructed systems such as these, which are conceived as nature-based solutions, and where the express intent is often to reduce a building's environmental footprint. In a recent study we conducted within the Circular City Cost Action, the contribution of green multifunctional envelopes was explored. As the actual water demand of plants is highly dependent on various geographical, climatic, and physiological factors, a case study was used as a methodological approach to simulate the potential for meeting water demand with rainwater and grey water availability in model buildings located in a cross-section of European cities in Turkey and in Israel. The aim of this simulation case study was to assess the potential contribution of vertical greening system in an urban context to the management and recirculation of water, preferably rainwater runoff, but also grey water at the building scale. On the left side of the buildings, we have identified as typical or representative in different cities and in quarters that are most affected by urban heat islands. The buildings, their architecture, uses, social structures, community in the houses, as well as their lifestyles, were simplified in this study and characterized with the following parameters: ratio of facade area to ground area, occupancy as number of inhabitants per ground area, and grey water production rate per capita. The evapotranspiration performance of vertical greening system in Copenhagen, Berlin, Lisbon, Rome, Istanbul, and Tel Aviv, cities with different climatic, architectural, and sociocultural contexts, have been simulated, adapting and simplifying a well-established methodology developed by the FAO, assessing rainwater runoff and grey water as irrigation resources. we estimated the amount of otherwise drained or wasted water accruing in densely populated city center quarters with different urban morphologies. And then we compared this water supply to the water demand or water loss due to the evapotranspiration of vertical greening system located in different climatic zones. The potential to evaporate water in the different cities depends on the climatic drivers and generally increases from north to south. The figure on the left shows the potential evapotranspiration for the different locations differentiated by wall orientation and the provided precipitation over the typical year. The case study shows that based on the climate, architecture, and occupancy, it is generally suitable to include vertical greening system in runoff and greywater management. Among key results, I can mention that the water cycling performance of those vertical greening systems in the mentioned cities will be sufficient at recycling 44% in Lisbon to 100% in Berlin, Istanbul, of all accruing rainwater roof runoff, if water shortages in dry months are bridged by grey water, and then 27% to 53% of the grey water accruing in a building could be managed on its green surface. The climatic conditions, in particular solar radiation as the basic driver, shape the overall water management potential in each city. However, the examples show that the architecture can at least partially overrule the climatic condition, as it determines the greenable area, and the ratio of facade area to ground area strongly influences both runoff and evapotranspiration. Several issues could also arise, on the other hand, from implementing green roofs and vertical greening system in existing buildings, such as structural issue, efficient performance, and end-of-lifetime disposal. Regarding the structural issues, most buildings have load restrictions, especially all the buildings with roofs that were non-intentionally constructed to accommodate nature-based solution. Of course, the knowledge required to avoid structural problems already exists and should be implemented. Regarding the ecosystem disservices, compared to the provision of ecosystem services, research on ecosystem disservices, those ecosystem outputs that diminish human well-being caused by nature-based solution, is relatively scarce. Open questions include, but not limited to, fire resistance in vertical green system, the quality of runoff water from green roof, and air quality effects. Regarding future-proof nature-based solutions, critically, the long-term functioning of such a nature-based solution is seldom addressed, and one way to do so is to quantify how each solution responds to stress induced by water deficit, heat waves, and extreme weather phenomena. However, there is little empirical evidence of this, which limits mainstreaming and replication, mostly because climate change is an ongoing nonlinear process, and there has been a limited exposure of nature-based solutions to it. Regarding, finally, the policy framework, government regulations and incentives for implementing nature-based solutions in urban areas are diverse and differ among countries and among cities in the same country, and depend on the type of building ownership, age of building, and building area, among others. This dispersion can limit the application of green roofs and vertical green systems, which greatly depend on policy regulation for both financial and technical support. One way to overcome policy limitation when implementing nature-based solutions can be to reinforce the integration of nature-based solutions in building design, which is already contemplated in the energy performance of building directives, to help improve the energy efficiency of buildings and reduce heating or cooling consumption. This could further help to achieve the circularity and decarbonize objectives from a building perspective by 2050. In order to enable circular processes in the built environment through nature-based solutions, and by closing the local water cycles, moving forward to a more comprehensive evaluation of the climate change impact of buildings during their design, construction, and use will be key to performance in a carbon neutral Europe and worldwide society and economy in the years leading up to 2050. Thank you very much for your attention. Just a little acknowledgement to the cost action circular city. Thank you so much.
Thank you to you, Beatrice. We are in time, so we ask all the panelists of this session to switch off the camera, turn off the camera.
Okay, great. First of all, thank you to all the panelists. That has been a very interesting session. It was very interesting to hear about this amplified concept of living layers within the building, especially in the work of Katia, where we shift from, let's say, a human-centric approach to this concept of eco or selva, where actually it's possible to consider not only the let's say the comfort of citizen, but also the comfort that allows for vegetation and biodiversity to prosper. Thank you so much also, Roberta, for sharing some insight from more experimental physics-based modeling of how a green functional layer may act within context of heating cities. And also to thanks for proposing some example of architectural implication. Last, thank you so much, Maria Beatrice, for sharing some insight coming out from the cost action that you nicely represented, and also to bring some practical point as a conclusion of this framework, and some consideration that help on the actually evidence-based implementation of such type of solution. Very interesting also the fact that you brought the layer of water into the discussion. So the question was very interesting, and surely there are some questions. Emanuela, would you like to start?
Okay, I just looking if audience have sent something, but at the moment
yeah. Meanwhile, I'll pose some questions myself.
Yeah.
Yes.
Yeah. I also have some questions, but more than questions, curiosity. So
go ahead.
Yeah,
yours,
I have one curiosity for Katia. Do you say that you simulated microbiota part of the system? I don't know. And I'm really curious because I'm really interested in the microbiota aspect, but in the human, in the person, the human. So how do you take into account the microbiota in your flow?
So thank you for the question. I'm not personally doing that, of course. So we have a very skilled and big team of ecologists that is working on this aspect. So right now the microbiota is considered along with soil. So they will be integrated models. And we are running in the consortium, and the ecologists are running experiments. So this is a very undergoing process. So we will get to have more results and more insights of that in the next couple of years right now. So, but what I can answer is that overall the ecological aspects are always considered and simulated through these models, which are local, but also connected to the regional scale. So the aim is always to connect so building form geometry, and especially the amount of soil which can be placed. This is going to be a very important parameter for the design, and to see according to these parameters what could be actually what could reach the ecology. I hope I was able to answer your question. For further question, I can of course give you the contact, so you can find on our Ecolab's website all the details of the people that are working specifically on the microbiota part.
Okay, thank you. It will be connect directly with the biomass part, I think, I suppose. So.
Mainly right now with soil.
Okay.
Mainly will be connected mainly with soil.
Okay, thank you. And then, okay, another question for Roberta. Yes, in your experience, what is the better way to take into account the green layer, for example, in a building model? How do you take it into account? Because normally it's just like a part of insulation or like a thermal mass, normally.
Thank you, Emanuele. Thank you so much for this question. Very good question. We worked about this issue because in general the software is therefore not so appropriate for simulating the behavior of the green walls in detail, best for the roof or for horizontal system, but not for green walls or green facade and so on. For this reason, we decided to use the parametric method to optimize and to use the measurements to find a lot of variables that can define the insulation, the thermal mass, and also the evapotranspiration of the green walls. So we find that there are some range, and this is important to stay inside this range. For example, for the insulation, when you consider wall or green vertical systems. And this is an important aspect, not only in the summer, but also in the winter, if you consider just insulation depth. So I think that this is a very important aspect also for the honesty of the materials, as we can say. So we not consider a lot of the insulation because there is a contribute for the green wall. For the summer, we know that there are a lot of important aspects because for starting from the evapotranspiration, we have a good contribute, but also for this in the models we have a lot of limitation to describe and to model this system. So we decide to use, for example, Galapagos to define some specific aspect. For example, the humidity of the substrate, the water contents, and so on, that usually can schedule it and not measured. So there is a very complex aspect, but if we consider a parametric approach, we can solve a lot of complex aspects, and so we can have a better simulation and a better design.
Thank you, Roberta. And then linking also with this, the last thing is for Beatrice. I know the work that you present because I was with you in this course action. So do you have any other result related with the evapotranspiration, or how the evapotranspiration can mitigate the urban heat island? Do you have some result of this? Or?
Well, actually, what we are trying to do now, hopefully new projects will be funded, so we will have some more opportunities to develop. But the idea is not to work with the building envelope, say, on a silo thinking, but try to build on this multifunctionality. So that's why also evapotranspiration is so relevant, because basically through those vertical greening systems, we could actually exploit several aspects. So it's not just, say, the cooling effect, which is probably the most studied and most known, but the key aspects are related to including, for instance, a pollution sequestration, because this is also very relevant for decarbonization. Also trying to reduce the runoff, especially the roof runoff, which is a key aspect, especially in many cities in Europe where we do not have enough, say, green roof installed. So it's not just, focusing on a specific function of those vertical greening systems, but more try to build on multifunctionality. So several studies are ongoing. It took us a lot to model, as you probably remember, because you were also part of this study. It took us a long to model in different cities. But now I think we need to be more specific, and also, as Emanuele was mentioning, trying to build on this evidence-based design approach because again, in this kind of projects, for instance, the truly interaction between the ecological elements and the architecture is not always very well exploited. So we need to build more on this, say, research basis to build on this.
Sure. Thanks so much. I think it almost looks like you have a logical connection and future cooperation between you panelists. It seems that perhaps throughout education or throughout even the center of our works, we need to move forward from the classic type of intending the building, or the classic of building physics, towards more understanding of the ecological layer. So almost this will probably in future here bring a stronger voice in our professional endeavors. I have perhaps a consideration which is related by from the complexity of the topic. It's clear that there is a lot of gaps that needs to be covered, and is an area, very charming area, as it will entail the need of involving knowledge as it happened in Ecolabs from different domains. I found very interesting also a way to have a parameterized control of the several factors. There is several, let's say, physical interrelation between the happenings related to living system, as well as temperature, pollution, water, and you name them. A complex problem, and perhaps I have a quick set of questions for all of you. I would start from Beatrice. You spoke about somehow you gave a technical presentation, but I know that in your research there is also quite a high emphasis on understanding the qualitative aspect of such type of technology. So how do you see a system that evolves encompassing both the metrics, the performance, and the qualitative aspect? Yeah, that's the question.
That's a very, very key question, Emanuele, because honestly, even taking the example we developed with the cost action, you would remember that I mentioned this, say, parametric study whereby we were able to apply, say, an equation in order to estimate the reference evapotranspiration. Well, this equation does not take into account any kind of design aspect. So basically, the green layer is a green layer, which I mean means nothing to us as architects, and so honestly, there is a lot to be, say, studied in terms of specific quality of the design, which at the end is what matters. Because, you know, if I have several examples, even in my city, of green walls that had been installed, but, you know, after a while, they become ugly because they were not really designed in the appropriate way. So, yeah, science and research is very relevant, but there is still a huge limit of it if we want to bring quality to the urban built environment. So there is a lot in terms of cooperation, because honestly, design should come from us and not from, say, other specialists in this research. And so, yeah, it's a key question, because without quality, I mean, no matter how many or how much in terms of ecosystem services we can module or we can simulate, but people will keep not installing this vertical system, because at the end they are actually considered a cost. So a problem, you know, if you have to maintain, and there you are a big company like the Caixa Forum that you have in Madrid, that of course is 2,000 per square meter installment, or basically nothing will happen. So thank you for raising this problem of quality, very relevant one.
Thanks. Knowing you well, I couldn't resist to ask that. Okay. I have a question for Katia. Congratulations on this project. It's more a curiosity. Is there any contrasting performance when we look at what, let's say, human settlement would ask from a performative greenery, which is more or less aim at perhaps create comfortable interior and enjoyable and microclimatic temperate exterior. But also we are talking about creating exterior or why not even interior for other type of species. Is there any contrast or any between providing space for human and space for insect or birds?
Thank you for the question, Emanuele. There would be, for sure. So what we are going to do is that we're going to validate and to assess how, first of all, human will accept the presence of animals, especially, but also of plants in their surrounding. So with Francesca Mosca, a colleague from my department, we are developing also some questionnaires and surveys in order to understand, to start understanding this issue. So from one side, we have like the interaction issue, so how people, humans, let's say, like it, which is of course very important because you cannot place let's say, for example, rats in a place where humans don't want to have them, so this wouldn't work. Then we also have the issue of ranking the KPIs, thresholds, and design objectives. So we will not be able for sure to optimize everything. So we will have to do some choices, and choices in our view and in our design process will be based on the what we call the design brief, so the identification of design objectives. And then depending on the specific objectives of the project, we will be able then to give more space to some types of animals, for example, to give more space to humans, or to focus more on thermal comfort, or to focus more on other aspects. So it's all a matter of balancing, I would say. So we don't have yet actual Ecolops designs that we can test. We are now in the process of developing the platform. So we really look forward to this next step of the project. So maybe in the next webinar, we'll be able to further discuss this aspect.
Sure, it sounds very interesting, and it looks like the one who needs to adapt in this picture is the human. Yes.
Yeah, in a way, but yeah, but at least like buildings are built for humans, so we have to adapt. But yeah, it's a tricky point, I would say. Tricky aspect.
Sure. Thank you so much. Thank you. Very insightful. I have a question for Roberta. I know that your interest is much wider than the presentation you're given now. You also collaborate with experts within the field that come from botany and related topics. In your experiments, which are, let's say, physics-based, you provide a performance. And I know also that you have an interest in meteorology, as well as an interest in tracking climate change. Perhaps the question is, if you have to think of these designs, this physics-based design, and how they could or may evolve in order with microclimatic changes, what could be an interesting type of strategy? Yeah.
Thank you, Emanuele. This is a big question. Very big question, very interesting question. Yes, I think, as you just said, it's true. I have a big interest in also meteorological aspect, micro meteorological aspect, because I think, as I showed before, that the initial conditions and boundary conditions are a very important aspect for this problem, because we are considering complex problem. So I am a physicist, so for me it's natural to think so. But I think that because I work in the chaos theory and in the butterfly effect, so I know that there is a sensitive dependence on initial conditions, and so when we consider a microclimate assessment, and so we consider the values of temperature, humidity, and so the representative scenario, there is, if we have not so careful, there is a propagation of this, and so a recursive error. And so we have, for example, in the simulation, an output that it's not so close to the real situation. We tasted this, and so I think that it is important to use the real data. It's important to don't use the database. And so when we consider some model, we have in a very user-friendly way some behavior of the meteorological data that could be considered representative, but I tested that they are not so representative. So in DPW, weather file, and so on. So more attention on this aspect. That is the initial, the first aspect, the initial conditions, and also on the boundary condition, as said before. This is a focus point from my point of view, of course, because but I think that we have considered for a long time a linear system, the architecture process as a linear system, and it is not linear. There is some complex aspect, and I think that we need to respect this complexity, because architecture is a very complex aspect.
Yes, yes. Thank you very much. With this word complexity, we can sort of wrap this session. We want to heartily thank you for having attended this panel, and I've shared several insights. I hope next year, if we are able to repeat this event, we will erode some space from conventional, let's say, type of construction, and expand much more the topic towards this niche that seems to be super interesting. So thanks for being here. Now we continue with two small presentations from us, from myself and from Emanuela. The overall idea is to present something a bit different from yesterday, something that join through the sampling and showing some example that are different from those proposed early morning yesterday. We are going to perhaps try to connect to the topic exemplified within this phenomenal array of speakers. So I will probably get the control now of the screen. Okay, thanks. Yes, so for those that just connected, my name is Emanuele. I'm a professor of technology and architecture, currently working for a few entities that are listed here in the presentation. Okay, at the moment I'm collaborating primarily with UNSW in Australia, working with Professor Santamuri. I'm also working in the University of Berkeley with Professor Stefano Schiavone, and keeping my endeavors at the Royal Danish Academy, where I've dismissed some activity, but I continue to be involved in the Master of Architecture and Extreme Environment. I collaborate also with the School of Sustainability of Mario Cucinella and with University of Parma. We have several collaboration ongoing. half of which relates to master plans, consultancy, building, sustainable buildings type of construction, and also ongoing research primarily related to how architecture and urban planning should answer to the threat of climate change. And linking to the past session, my idea was to show some cases, beginning from those that relate to living system. Primarily working with Mario Cucinella for creating the bed for future development within the Italian context, we try to understand how climate will change. This for a set of reasons. Some are related to decarbonization, create buildings that use less energy, and allow the creation of positive energy type of district. These are projects that are actually ongoing in the center of Italy primarily. But also try to understand how can we create the layer that sustain ecology. And last but not least, human health. It's a big factor within this thread of research. It's very interesting how today we are able to project for future climate the thermodynamic happenings that characterize water, that characterize different type of tree vegetation, as well as building, as well as human behavior, and we can then predict in an accurate way how a site may evolve. First of all, it's becoming super important for us to calibrate our models, which means that contemporary scenario and set of temperature, in this chart air temperature, are coming from the context. When we look at this line for 2050, we can see how temperature of air for different pixel within a city leads to very different type of temperature, with, for instance, overheating represented into red. And despite there is a big emphasis on the issue of urban heat island, what we find out in several of our studies is that more or less the city is the layer that is more resilient to climate change. Indeed, if you look at the delta temperature, which is the increase of temperature that we have from 2050 and 2022, and if we continue to look at the red colors, the parts that are more threatened by the boundary condition change due to variability in climate are the living system. Living systems are threatened because they have a comfort, perhaps as explained by Katia, Professor Katia Perini before, which is very specific. Furthermore, we also inputted into the model the hydraulic flow, and what we can see is that less availability of water can become a threat. And we can see this, for instance, for the agricultural site, as well as for part where the hydraulic flow are minimized. And needless to say, also greenery into the city, it's a big issue. What we did is to create grasshopper script, which are linked to historical data and variability of different type of data that come from environmental agency. We put some emphasis in understanding how, for instance, the ecological status of water bodies may change, as well as we try to understand how hydraulic flow, you can follow this line, are going to be reduced by climatic type of happenings. Furthermore, we inputted the equation of correlation between thermodynamics and pollen concentration. So we can see how this is declining, and we know how this is very important because they are at the basis of actually several systems, both the food chain as well as of biodiversity. We can see also how certain type of species will be on declining, as well as the pollinating insect, which already, according to historical data, were declining. We can see how steep it is, this curve that reaches from 2000, only from 2000 to 2020 is steep. But what you can see is that the outlook, according to the parameter and the equation we found in peer-reviewed literature, it's on the decline. Furthermore, if you look at air pollution and how climate change is impacting that, we can see how concentration of certain particle, despite scenario electrification of transportation, how this will be a problem. We could also have access to medical data and find also correlation into literature that allows us, for instance, to talk about respiratory diseases, how these are modified, and also very interesting and a huge problem is those of skin cancer that were in the rise, and this is definitely related to the changing in atmosphere and the ozone hole amplification. It's also interesting to look at circulatory type of diseases that have a different trend. This because different lifestyle, more sports, better diet, actually it's a stronger force than the problem related to climate change. We have also other data related to mortality and morbidity, but I will not include in this type of presentation. So the first outlook of this workshop that perhaps can link to this project is that although this conference have had an emphasis on, let's say, the classics domains of what we can call today sustainable design, or for some of you urban sustainable design, or for some other this relates to the let's say technical physics related to that. But a first output that perhaps came out from the first session is that we need to think multidisciplinary, involve much more and coordinates our data, let's say in a mathematical way, in order to have outcomes that can, in a more holistic way, consider several implications. The second work, it's developed with Professor Jonathan Nathaniel and Professor Francesco De Luca, respectively from Technion University and from Tallinn University. We have several collaborations ongoing. And this work, led by Jonathan, try to understand how urban morphology can sustain this layer we just mentioned. So if we look at conventional way of building, probably we go for a catalog of solutions that are more or less belonging to a local type of vocabulary. But we can extend the form making, including other parameters. For instance, how can we create already self-sufficient forms, perhaps those inspired from biology? How can we do multi-performance optimization, where the parameter is not only energy, but is also qualitative factor, for instance, related to solar exposure, or why not by extending the chart elements such as photosynthetic activation. And this may lead to a new type of construction. And it's very interesting then to relate to what was already built. Specifically, we work for long with the TU Delft, try to investigating how Venice is reacting to climate change, how the biolayers of the city are contributing or not to climate change, and how those are treated by climate change. Interestingly, also there is a correlation between, for instance, vegetation and biodiversity within a site and urban morphology, but also there is a correlation, for instance, to and an influence to how characterizes the microclimate by living system and the energy consumption that you may have within buildings. So it's quite interesting if we look in the last row to the changing of temperature that we have in different parts of the cities, to see how there is a substantial increase of temperature within certain areas, whereas in other, like in this one, although we pass from 2020 to 2050, the indoor temperature within the building are basically kept. This co-modeling or chaining of different models between indoor and outdoor that characterize the first day becomes something very interesting and something very very needed in order to achieve a performative and qualitative built environment. Other type of work done with my Danish academic affiliation are done in Chile, in the city of Atacama, very much threatened by climate change, where the idea of this work was conducted in strict collaboration and through the helps of a student that I would like to mention, Amy Desert, was to track and sensorize a series of buildings as well as the outdoor environment as a way to have a full year of what we call a climatic happening within the city. These charts are then used as something that is going to impact and inform the design of the city with an approach which is not related to mitigation and modulation of temperature that would imply more use of energy, but the concept of planning is here based on the acceptance of the change and the understanding of what bio layer would fit within the picture, what type of vegetation, what type of local animal, also considering the proximity of the desert, would be adaptable to the city. As well, when it comes to human activity, the idea is not anymore to force and to have environments that are cooled, but the idea is to try to fit the program to the different thermal happening that you have on the site. And this also is quite interesting when we insert, for instance, future climate projection and try to understand with thermofluidodynamic what are the different conditions that you have and how this can be influenced by the making of new type of forms. Therefore, you create a series of atmosphere that can host life in different type of forms. Keeping on this narrative, I would like to mention some early collaboration with the big Bjarkeningel office, where, for instance, this educational center in the Faroe Island was shaped by the idea to adapt to climate change, with the idea to create zones where, independently from the direction of the wind, there is always one zone into comfort. Which, as you can see here from the development, may give a different microclimate, which then become the setting for a different type or for the creation of an outdoor room with different climatic characterization, making this perhaps a regenerative project where you can always be in a comfortable spot around the building. You can see here how the shape here on the left, it's almost coming from a windrose. And relating to the title of the workshop, which is about climate change, differential of temperature with different sea and earth are definitely changing due to climate change. So traditional patterns that are even established and that even are used from navigator within the sea are strongly affected by climate change, and it's very important to have building that offers an answer to this type of variability. So this is the concept implemented in the early discussion we've had for this type of project. I would like to, perhaps for the sake of time, interrupt here. I had several other projects, but I think it's worth to leave the time to Emanuela, so that she can present her project and reiterate on this platform that may be very interesting for hosting collaboration with all of you. So I will quickly try to click. I'm sorry for this scroll, so that you can then have some space. Perhaps I'll want only to conclude with this chart that I prepared for this workshop, that summarize a little bit the design direction that have come out. This is sort of a let's say a small conclusion, and what we can see here is that somehow there is there has been quite a shift of many of our focus from the building side to the urban climatic resilience. I could see in the weighting of the presentation, but I can also see how somehow, especially today, there has been strong emphasis on bringing research toward the side of thinking of how the living system can be a part of a strategy of adapting to climate change. So the envelopes, as expressed in this chart, regain a certain interest, and also it would be very interesting to think, like we discussed yesterday, of envelopes that are able to become intelligent mediator between the outdoor and the indoor. With this, I will leave the word to Emanuela.
Okay. I have the command now. I don't know. Yes. So, what is happened? Okay. Thank you. Yeah. Good. No, it seems I haven't. Okay. Now, yes. So thank you, Emanuele, for your presentation, and it's really pity to to stop you, but we are more or less in time today. So I like to close the sessions with reminded which is the frameworks of the organization of this today webinar. Thank you, Emanuele, to help me to organize it, and thank you to build up to host this today. And thank you for your help in the presentation also. So the framework of this webinar is in a national project that I'm leading here in Madrid called Urban therCOM. Urban therCOM is related with strategy for modeling urban material for more livable city. In concrete, we are here in Madrid. For the people don't have met me before, I'm a researcher at CIEMAT. CIEMAT is the Spanish National Center for Energy, Environmental and Technological Research. Next, please, because it not work now. I don't, okay. CIEMAT is divided in 5 big departments. I'm in the Department of Energy, and specifically, I'm working in the energy. Oops, sorry. In the energy efficiency unit. The activity that we develop is most related to energy and building environment. And in this line, I'm leading this project that is called the Urban therCOM, that is part of the big coordinated project MATEMAD. The project is really related with all the speech that we have yesterday and today, because it start with the hypothesis that the use of optimized materials can improve or can mitigate the urban heat island effect in the city. So the project is divided in three sub-projects. The first one leading by Instituto Eduardo Torroja, that is from the National Research Council, and they are leading with the characterization of urban materials. So all these topics related, for example, for the both with speech that we have today, for example, with Ioannis, or the speech that we have yesterday also, and the sub-project 2 that is leading from the Faculty of Architecture of the Polytechnical University of Madrid, and they lead with monitoring of the environmental parameters. We have already spoke today and yesterday in the topic to have and to lead with the data and to have real data and to have good real data also, and to be able also to calibrate our model. That is, for example, the aim of the third sub-project, that is mine, that's urban therCOM, that is most related with the modeling outdoor. So the project starts with the assessment of the vulnerability in the city of Madrid. So this also another aspect that is related with the topic of climate change, because we need to have relation with the inhabitants of the cities. So as we have already said yesterday with the project of Carmen Galan, and yesterday for some project in the speech of Jesus Lizana. The second step of the project is the thermo-optical characterization of different material, and this is also related with the other speech that we have today. The third is the monitoring, as already said, and the fourth is the modeling strategy. The last one part of the project is give the optimum results, the optimization of the results in the sense of life cycle assessment. At the moment, we had already identified our case study, and we had done this in the sense of severity of vulnerability, and this vulnerability is based on the energy poverty index, urban Italia intensity, but we also want to relate this index with the morphology of the city, as we already seen today also with the speech of, for example, Maria Beatrice. We need to know the topology of the city and in the better way. So we choose our case studies in the sense of vulnerability, but also in the sense of morphology of the city. And for the part of the simulation, we have developed a strategy that is a grasshopper-based digital workflow. Most of the presentation that we have yesterday and today are also based in this kind of strategies, because it gives the possibility to simulate the different physical domain in the same workflow. At the moment, we had developed a really little part of the simulation workflow. We have developed simulation for the thermochromic coating in a single test room, basically here in Madrid. And we, for the future, we need, and I am really happy to have meet all of you there, because you are very inspiring for me and for the next steps of this project, in which we have to put all together the environmental part and the energy part and the envelope characterization of our building. So that is all. It's just to close, and I'm really glad to have met all the friends and colleagues, to meet new ones, and I hope we have possibility to collaborate in the future in these topics. So now we open the session for conclusion discussion. So every panelist, all the panelists can switch on the camera and can participate in this part. So Emanuele, do you want to add something else?
Sure. I guess it's quite late.
Yeah.
We are all a bit hungry. We comply with Spanish time. This has been 2 very intense days. I would like to do a small wrap, which is very much needed after so much information, and then ask the panel if they have any consideration or points. I would like to stress how it was important to see different techniques for modeling the microclimatic changes. it becomes very important to use more accurate types of information when it comes to climate change. We also have seen how somehow most of us it's in line with the 6th report of the IPCC, which says that we have prediction of how climate change, which are quite site-specific and are quite specific also in terms of the cascade effect given by climate change. But what we are strongly missing, it's an answer from the built environment. It was also very interesting to understand more analytically throughout the session of microclimatic form and surfaces, but I would like also to include Jesus within the people that have discussed this topic. Actually, when we selected Jesus, he had such a wide number of interests that it was difficult to just limit to one, but what he showed is definitely related to the topic of microclimatic changes. And it was interesting to see how from one side there is a better way to getting important information on how design can evolve. But also we have seen how these layer of information are oftentimes difficult to be managed. So the work of Jesus as well as the one of Angelos goes into the direction of having information at the end that have more granularity. But also through Angelos, it was very interesting to see how artificial intelligence can help within the topic of mitigation. Needless to say, Agnese, Massimo, and also Carmen Galan have several projects that are already tackling the changes and are proposing a very contextual type of solution. But we have seen that there is no microclimate without an indoor climate. And somehow what the work in progress shows is that actually these are often considered as two different entities. So this dynamic and transient thermodynamic relation between indoor and outdoor really looks like something that should be explored further. Clearly, the workshop showed a gap within this direction, but it was very interesting to see how Naga from Technion is working on this field, as well as Victoria Lopez is working on the field. Try to link, for instance, the outdoor room of a courtyard to the indoor rooms that actually wraps courtyards. But it was also interesting to start with Michael Bruce from EnviMet, who is showing how his line of work is trying to consider even more this exchange between indoor and outdoor, and actually show us some pedestrian new tool that allows to trace line within a context in order to understand all the physiological patterns related, for instance, to a walk activity. But the next step he mentioned it's even to consider how when people move from indoor to outdoor and also the adaptation time. This is a current research in Berkeley, but also sort of rejudge the position given by UTCI, which is universally assumed by anyone. But if we look at it, it's a physiological index that has perhaps a subset of limitation that should be looked at. Therefore, for instance, researchers from UC Berkeley are trying to develop these new comfort models, which actually accounts from the transition from indoor and outdoor, and also the time of adaptation of people. So that was more or less was what we discussed yesterday. Whereas in the beginning of the session, we have had a contribution of related on how facade design may change. Very interesting to listen to the position of Miren that crosses those of Andras and those of Ioannis, Alessandro, Fabio. and why not also Jesus in his other life as a researcher, where we can see how envelope were primarily conceived as something facing the indoor, where daylighting and thermal indoor comfort have almost shaped what is the behavior of an envelope. We could see here how surfaces become a layer of the city, offering a certain microclimate. And needless to say, the very ample first session tried to add a functional layer in design throughout the layer of vegetation, layer of surfaces that makes energy. So the envelope is definitely the protagonist of this second day, where we can see also how climatic data discussed by Giovanni can be sort of the tools that will scape new type of envelopes. And we spend we had quite an ample session then try to understand how nature-based solution can impact and become an additional element within the city. So overall, a super interesting 2 days. I can see that in the panel we have a few left, and this is understandable given the time. Thanks for being so resilient and being still here. Perhaps I will just take the chance to go for a small set of consideration. Especially, I would be interested in the point of Jesus working at the Oxford cooling group. What have you taken out from this workshop, and how do you actually interpolate it with your center current development? Yeah, what can be some intake from that? Thanks.
Thank you, Emanuela. I think this was a fantastic seminar where we could learn from each other what we are doing in different scales. And I think that the most interesting thing that I identify, even working here and even from the seminar, is how important it is to try to do interdisciplinary research. And here is something that we can easily understand what others are doing and how we can connect with each other in order to find synergies with totally different areas, but areas that can match very well to the work that we are doing individually, from understanding much better the information of the climate and how understanding the climate we can define novel solutions for buildings that we can implement in real scales with novel materials and novel control ways. So I think it's fascinating to know what we are doing in a broad scale, and I think this is something that I think is the most important topic of the seminar, this interdisciplinary covering that we had in this fantastic seminar. Thank you.
Okay, thank you so much, Jesus, for participating. We really appreciate it. Perhaps we can ask Miren Gioristi Gutierrez. In your research institution, you have several line of research. You're involved probably in different type of projects. How climate change is modifying somehow the pattern of research of you and your colleagues? How do you see this as an opportunity within your context of research?
Thank you for the question. So, yeah, we are Eurac Research is a pretty big research institute, so really hard to talk in the name of all of them. And yeah, I work inside the Institute for Renewable Energy, and what I can talk more about is about the energy efficient buildings group. Historically, the group has been focusing firstly on how to integrate renewable energies in the built environment, and then going for energy efficient measures. And in this case, as I am part of the building envelope technology group, so you see it's a pyramid, really big one, so I'm more comfortable talking about specifically the facade development. So far, we've been focusing on characterizing the performance of the envelope technologies. And in the last year, since I am here, we have been also working on technology development. So let's say that the climate change is one input more, but we are not so specialized as you all are in the topic of the climate change and climate, how to go for better data, climatic data to do all our analysis. But I must say that in the last 2 years, we are shifting also our focus little by little with new PhD candidates and collaborations with the University of Padua and also Polytechnic of Turin. So I'm really looking forward to see how this research goes. And then we will try to see how to build a framework so that the facade technologies that we are developing are assessed also regarding the consequences of the climate change. So looking forward, and I know that other colleagues are also now working on resiliency, impact of heat waves, and so on. So I guess that in some years we will have more results. I clearly see this kind change of trend in our institution as you all have done. So yeah, looking forward.
Thank you, Miren. Roberta, do you want to add something? You are muted, I think.
Sorry. I would like just to thank you for this big opportunity. It's a great pleasure for me, and to meet a lot of researchers. And I think that this is a strategic partnership because we are all focused on the main goal that is to changing the world. I think that this is a very important aspect. I'm so happy to see Miren, that is so young but so involved in so interesting research, and so all the younger researcher. So I think that this is a very, very big challenge. And so thank you to Emanuela, thank you to Emanuele for organizing this meeting, this webinar, and to remember and reminding us that we are all part of the one project, and we are part of the nature. I think that this is the starting point. We don't remember this, and so thank you so much. Just only this.
Yes, before leaving the last word to Emanuela, which actually was coordinating a big effort. We had an intense collaboration to prepare this event, but we also want to thank CMAT through that where Emanuela works. Also, we are incredibly thankful to Build Up, to Arantxa, to Emily, to Daniel, and all these machines that really help foster high quality contents, or at least coordination. But contents are, needless to say, great. Thanks and through your type of participation. I wanted to finally ask if anyone else from the panelists wants to add any thoughts, and then I will leave the closure to Emanuela. No? Okay, Emanuela.
Okay, no, just say thank you that I already said. Thank you to all the panelists, the panelists of yesterday and the panelists of today. And as I already said, for me, it's really inspiring. And of course, I have new idea, and we'll keep in touch of some of you, because I have other many questions, but today we don't have all the time to have a big discussion. So, and nothing else. Thank you to Build Up to help me in this. Thank you, Emily. So I know the effort that you have, And thank you, Daniel, and Arantxa, of course. So.
You're more than welcome. It was our pleasure. So if that's all, I think we can wrap up for today. So big thank you, of course, to all the speakers, to Emanuela and Emanuele for your organization and patience. We really appreciate it. And we really enjoyed the last 2 days. And thank you also to the audience for attending. And a reminder again, of course, that you can find the recording and the slides on our Build Up portal. It will be next week. And we wish you all a really pleasant afternoon and a good weekend. So thank you all and goodbye.
Thank you very much. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye. Thank you.